All right, good morning, folks. Welcome to the last day of PISCeS. So I'm just going to introduce our first keynote speaker of the morning, Dr. Chris Wilson from the MNR. I managed to remember to not say the O.
Yes. We've had some horrible acronyms. I'm very glad to come back to Ministry of Natural Resources or just MNR. But it's actually kind of nice to be on the third day of this because there's been so many amazing talks so far. The bulk of any take-home messages I have, other people have already said and gone into more detail, which takes the pressure off me for hopefully timing, because I suck at that. But it's basically, this is the third PISCeS conference, and each time we've been able to move the goalposts farther. And so when Bob asked me to talk, I was like, well, the best I can do is give some storytelling on some of the projects we're doing. But the important stuff is where to from here. So that's where I really want to start in. And like Matthew said, I work for the Ministry of Natural Resources. Officially, the job title is I am the Research Scientist for Aquatic Biodiversity and Conservation. How's that for a pompous note? So that's the job. And, oh, this is not, okay, I'm going to stick to the old-fashioned way. No, I'm not. Oh, come on. It's too early in the day for this. Okay, while the technology sorts itself out. So I'm the aquatic biodiversity guy for the province of Ontario. And for those of you not from here, it's a big place. So there's a lot of ground to cover. And I may now have a pretty picture to back this up. No, I really don't.
Sorry, did you put the microphone?
Oh, sorry. I'm really not fond of these, so I tend to put them far away.
It's just this.
Okay, yeah, here I was using the arrows. See, look. I was thinking there was a vague chance that those were doing something different from this, but no.
No, that is actually what's
Okay, you drive. I would like a slide after this, please. So anyway, Ontario is fairly large. It's one of the larger provinces. It's got about 40% of Canada's population and a lot of biodiversity. So everything ranging from Arctic biome on the shore of Hudson Bay down to Carolinian forest in southwestern Ontario. It's a lot of ground to cover. And folks here from the US, you all know how Texas has bragging rights. Ontario is 50% larger than Texas. And half the population, so there's fewer of us to keep up on what's actually happening on biodiversity. So thankfully I've got an awesome team and they help me deliver on what I need to. When they catch up, we're going to fast forward through a few slides. So with the Ministry of Natural Resources, their job is, they briefly shut up. It's fun to watch this over here. Ministry of Natural Resources, it's the essence of management is sustainable management. It's not raw exploitation. You manage for the future you want in the present. So it's a democratic society. What future do we want, and how do we get there from here? Actually, that's a good slide to be on. Okay, good. So, one of the first things for sustainable management, I hope you've all heard of Aldo Leopold. One of my favorite quotes from him is the first rule of intelligent tinkering is keep all the parts. And for living things, that's biodiversity. So, all of you have heard of this, some of you may remember it. In 1992, the world got together in Rio de Janeiro and wrote the Convention on Biological Diversity, CBD for short. Canada was not the first signatory, but we were the first country to actually ratify it. We have some obligations, so there is now a Canadian biodiversity strategy to support this. And a few years after this, Ontario got on board, and we have a provincial biodiversity strategy. And rather than dragging you through the whole document, here's the important points. Biodiversity matters. So we want to conserve and restore what we have. We want to safeguard it against emerging threats and known ones like pollution, habitat loss, those predate climate change, invasive species. And again, sustainable management. What's the future we want? So this has gone through a number of iterations. The most recent version leads us up to 2030, and they're starting to figure out how do we want to get to the next step beyond that. Nationally, Canada made the global commitment to conserve or protect 30% of our lands and waters by 2030. You've probably heard of the 30 by 30. And there's talks about this already at the conference. And some countries are making great progress on this. There's one tiny little island in the Caribbean that's actually accomplished it already, whose name escapes me. I think it's Redondo. But you can find it. Canada's about halfway there. So we have a long way to go in very little time. And what's important to conserve? We don't even know what's out there, and this is one of the strengths of environmental DNA, is who's where. What habitats are they using when? So we need good information to make informed decisions in a very narrow time window. And this group of people is part of the solution. No pressure. So we want this to succeed. We need to embed this biodiversity in everything that is done across society. We need good information to do that. So I'm going to have a few just so stories, little projects we've done in the lab. We already know eDNA is a really potent information tool. And in the early years, the bulk of this was targeted single species of interest, whether it's setting off alarm bells or it's something we really value but is hard to find. So you've all heard of Asian carp. It's what made eDNA hit the headlines big time. Thankfully, that photo is not from Ontario, but those are 3 of the 4 carp of the apocalypse. And we're working on trying to make sure they don't get established here. The 4th one's a different story, and we'll get to that. I do want to talk about marbled crayfish in the top right. They're cute little guys. Through no fault of their own, they are established in Ontario, and we're trying to prevent them from spreading. And Stephanie Coughlin talked yesterday about some of the work we're doing on aquatic invasive plants, as well as biodiversity. And again, with the targeted approach, one of these keys will work, one of these keys will not work. Okay, this is me, not the technology. Kate, can I get some help? I should not be allowed near technology, including microphones. So we've also used the targeted eDNA for looking at endangered species. Bob and I recently had a student, she was looking at eDNA of red-side dace to document habitat occupancy and revisiting a survey that had been done 10 years previously. And the news was better than we expected. They're actually still hanging on. Until this, we thought we were essentially losing 1 watershed a year. And their Canadian distribution is pretty much the Greater Toronto Area, which has also got the most rapid population growth for humans, so it's not good news. And this was Lenka Trivet. She's also working on silver shiner. Can you stick around, please? What did you do that worked?
I'll just do it.
Okay, sure. So we're using this for looking at endangered species and where are they, because rare things are hard to find. And 2 projects where Fisheries and Oceans is actually doing something for endangered species recovery, going beyond writing recovery strategies and government response statements. Fisheries and Oceans is actually doing translocations of endangered species back into suitable habitats where they're no longer present, and that's these 2 on the bottom. So eastern sand darter, and I'm actually getting the latest samples tomorrow to test, and kidney shell mussel, that little guy on the bottom right. So I work in a provincial agency, but the acceptance and adoption of eDNA is really varying by program group. So Per was talking about it yesterday. You can get funding for invasive species much easier than you can for biodiversity. Most of our eDNA work is funded through invasive species dollars, and we piggyback little things where we can. So for invasive species, this is increasingly the tool of choice, and they want our information and they rely heavily on it. For endangered species, they're interested, but it is not accepted on par with, I've got one. If you can hold it, photograph it, that's real. eDNA, well, we'll take it under advisement. And for sort of species of interest, and brook trout is the lab rat I'll be talking about today, or guinea pig, there's a lot of interest. For biodiversity, there's some uptake, but no serious buy-in yet. And I'm in the Ministry of Natural Resources. Parks and endangered species are now in Ministry of the Environment under a new name. I won't burden you with other acronyms. They won't accept it yet. They're interested, but they're cautious. And part of this is people do not have a good understanding of what it can do, what it can do, or can't do, and the nuances of interpreting it properly. If she explains it enough times, I'll eventually get it. So, Asian carp, carp of the apocalypse. The Ontario program is quite a bit smaller than what's going on in the United States. So if we have limited resources, we invest them strategically. So spring sampling is targeting potential spawning areas. So rivers that have enough reach and flow that they're attractive to the different species of Asian carp. Summer sampling is more, where's their foraging habitats? There's absolutely no point sampling the middle of Lake Erie because if you get a detection, what are you going to do anyway? So it is this strategic sampling. This is targeted testing for all 4 species of Asian carp. Xenocarps is what Fisheries Notions call it now. Hitting the right button. And I don't expect you to read all this text. But basically, until last year, we would get sporadic detections almost entirely of grass carp. It was like little blips static on a screen here and there, and it was like, fine, we're not worried. That all changed last spring. The spring sampling that was done in late May and early June, we were finding them we got detections in rivers, and it was multiple detections in several rivers. So I'm hoping you can see it on the screen. The blue dots, those were spring detections of grass carp. And they're in the Sydenham and Thames River that feed into Lake St. Clair, the Grand River in the eastern basin on the Ontario shoreline. And these were repeated. And when we have a positive for invasive that's sort of high risk, we repeat the testing and we sequence it. And then we count it as a confirmed detection instead of a potential or putative detection. So it changed last year. And the folks on Lake Erie are taking this seriously enough, they altered their sampling to put in an earlier spring sampling now. And we're just going through those results now. And I'm told I'm not allowed to tell you what they are yet. The joys of working in a government agency. Another species we're keeping an eye on is tench, tinka tinka. It's creeping into Ontario waters through the St. Lawrence. And we had done a number of samples for metabar coding, biodiversity assessment. And Fisheries Notions allowed us to deploy some passive samplers along some active netting they were doing for Marble Fish Community. And these passive samplers, which are very low-tech things, it's a filter in a wire mesh cage, that's it. We picked up tench. With metabar coding, we followed up with targeted testing to confirm. So, I'd love to go into more detail on all of these, and I just can't. Steph already talked about the plant stuff yesterday, so I'm not going to go into it, but it's targeted testing for hydrilla, and we were able to piggyback the metabar coding for biodiversity on top of that. So I'll come back to it, but most of the work we've done to date has been targeted, single or few species. Personally, I think metabar coding is the way to go going forward. The technology has come so far. It's fast, it's cost effective, and you get much more information in return that can be used for multiple purposes. I did mention the marbled crayfish. I am fond of these little guys. Briefly, they're asexual. So if you have one individual, you have a breeding population. And 600 to 700 eggs about every 6 to 8 weeks. And they're brooders. So they're established in Burlington, a few kilometers away from Hamilton Harbor. So about an hour's drive from here. And we're trying to do eradication. They were first reported by iNaturalist by photograph. Somebody said, what is this? And that caused all kinds of uproar. We were asked to do eDNA testing. Ontario Federation of Anglers and Hunters went out, collected water samples for us multiple times while they searched. They could not find them. And we kept getting detections, and they were getting stronger and spreading. So based purely on faith from the eDNA results, the city of Burlington drained these ponds where they were first seen, or first photographed, to try to freeze them out, kill them off over the winter. Didn't work. But without seeing an actual specimen, they said, okay, this is risky enough, we'll do it anyway. It took almost 2 years until somebody caught one, and I was in the middle of a call explaining to people how, yes, you can get positive results without living individuals present. And somebody from Anglers and Hunters was trying to break into the call saying, we got one. So it was a nice vindication that eDNA works. Since then, Fisheries Notions has had an active removal method. They've removed roughly 4,000 so far. And Burlington is draining the ponds every winter. They're trying to get approval to have a poison treatment. Permethrin, the same stuff they sell in the US for mosquito repellent. It's very nasty on aquatic inverts. But they're doing this because right now they're contained and we're trying for eradication. But all of this was based on 2 years of eDNA detections with it before we could actually see an individual. So I'm fond of them. And a broader survey across southern Ontario, we don't see any other evidence of established populations. So far, containment seems to be working. Excuse me. For the fisheries folks, they're very interested in this for brook trout, and we've used them for all sorts of testing. I won't go into detail on any of this, but the map on the bottom, one of my colleagues, Nick Jones, Andrea knows him, has deployed multiple crews going around to say, our brook trout here, the habitat modeling says they should be, but do they coexist with rainbow trout and brown trout? It's a fun little project. So you already know all of this. eDNA is fantastic for rare or hard to detect species, patchy distributions, hard to access, many advantages. And for the mussel people in the room, that photograph on the bottom is my favorite non-fish, wavy raylet mussel. So for those of you who don't work on mussels, the thing under the supposed fish, that's the organism. The fish is the lure it uses to attract hosts for larval dispersal. And eDNA works wonderfully on them. It's one of the few cases where I'm comfortable you actually could get quantitative estimates. Matthew and I have debated this for a number of years. He's an enthusiast and I'm a skeptic. So it's a good debate. But the bottom line is this is a very, very effective tool for finding out who's where and informing policy and management decisions. It's kind of fun when you pair technologies too. Briefly, one study where we can, I didn't realize I was holding it too far away, sorry. One study where we combined two non-invasive technologies was hydroacoustics and environmental DNA to figure out species composition. This was in Lake Opiongo. It's a large lake in Algonquin Park in southern Ontario. So there's a hydroacoustic profile. You can see there's lots of fish, but you can't see who they are. You combine it with eDNA and you can get a look at it. So we ran 4 different time transects, dawn, dusk, just before midnight, and between 3 and 4 in the morning. Combined this with netting and eDNA sampling. We needed the netting to calibrate. So could we figure out who's where when? And the answer is yes. And basically, these are eDNA detections at multiple depths over these different time slices. I will not bore you with the details. It's in environmental DNA if you really, really want to look it up. But it was fun to do. Basically, we saw them moving around. As fish moved to different depths, the eDNA came with them, and then as they moved on, there's a lag effect or an echo, which complicates things a little bit. But basically, it was a potent combination. And I lost the debate with Matthew because for netting, we have biomass of the different species. And when you use the netting against the hydroacoustics and eDNA, you can actually estimate abundance. So you win. But I'm not giving up totally. If you look at some of these plots, there's some dots right along the x-axis, some along the y. So we have 2 methods of imperfect detection, calibrated with a third one, netting. All our tools are imperfect detection. The public does not realize this. You guys all do. And for eDNA, we're also dealing with patchy, chaotic distributions, not uniform, not random. The public doesn't recognize this either. We have some communication to do. So it is a very potent tool, especially when you combine it with others. Now, I was saying I really think that the metabar coding is the best way to go forward in the future. We can keep targeted for specific questions, specific applications. But with the metabar coding, you get a wealth of information that can then be used for multiple things. Our biodiversity sampling so far is driven by invasive species funding. The province just scrapped or radically revised, depending on who you talk with, our endangered species legislation. Good luck getting funding. But invasive, yeah. So our lab's first steps into this, Stephanie drove this. This was looking at community composition of mussels funded by Fisheries and Oceans, testing out different assays and comparing against long-term data from quadrat sampling. And no method was perfect, but the eDNA was far more effective with less effort for determining species composition. And this is published, so I'm not going into details. You can see, just by bubble plots, similarity among locations, and differences among different watersheds. Again, no need to go into the detail. We used 1% of the total read per run as our minimum cutoff. So you can characterize communities. I'm not giving in on quantifying abundance on this one. Metabar coding has additional caveats you have to meet, but it is a powerful tool for documenting biodiversity. And if we're going to be meeting this 30 by 30 target, or even just living up to our species commitment on not eradicating everything else, we need good information, and this will get us a lot of good information quickly. Stephanie already talked about the aquatic plants. I don't need to go into that, but basically this was a hard sell to the M&R people, because why do aquatic plants matter? And then you say, oh, juvenile habitat, nursery habitat for young fish, the fish you want to catch. Now it's important. So a lot of it is just the communication and talking. And one recent project that we're both involved in is kind of fun. This Steep Rock Mine in northwestern Ontario, it's very close to the town of Atikokan, close to the border with Minnesota. Just before World War II, there was lots of prospecting going on, and they found virtually pure iron ore at the bottom of a lake. Pure enough, you cut the ore out, it goes right into the smelter, and iron comes out. So they drained the lake to do this. And this was part of the effort for World War II. We need steel, we need metal for weapons, etc. The mine closed in the 70s. They're allowing it to fill back in and basically hoping for natural rehabilitation. So the local biologist said, hey, you want some fun? Can we see who's recolonizing? So we tried this, and we've got some hard lessons from it. Number one, you cannot do metabar coding, or we can't, in a lab where you do population genetics. We have workarounds for the single species targeted. For metabar coding, no defense. So here's one example of some of our results. We have contamination in here. We have species that only occur in Lake Erie, supposedly occurring in a mine in far northwestern Ontario, because we included samples from Lake Erie for a project for DFO on the same MISE run. This caused a lot of angst and a lot of pain, so we've learned some hard lessons going forward. The upside for this, that was the lever I needed to finally get the M&R to give us dedicated lab space for metabar coding. Because I could go to the managers and say, look, we're producing bad data. Either give us proper space or we need to stop. And they gave us proper space. So one of these lakes is quite toxic if you go below more than about 5 meters. I would not recommend swimming here. But fish are recolonizing. I'm not going through the full data because it's more actually important to show the bad things, the contamination. And hopefully you guys don't have to repeat our mistakes. So there's lots and lots of applications. Everybody knows this, and I don't need to work through this list. So from the management perspective, the agencies are starting to see, yes, we do value this for things beyond invasive species. My personal driver, I really want to see the long-term information contributions so we can manage intelligently and informed, because we need to. One of my nicknames at work is Dr. Doom. We're in the middle of the 6th biodiversity extinction crisis in the history of the planet, and we're losing species at the same speed as they did back in the Permian. So we need good information to keep what we can. But there's challenges for people to accept this information. You're trying to persuade people there's an invisible man standing right next to you. People won't believe you. And for years with the eDNA, you probably all experienced, show me the species and I'll believe you. I don't know how you do that for aerial work. But Liz Claire had a great example from bats yesterday. So part of it is just, we're living in an increasingly skeptical society when it comes to science, but a very willing belief in technology. And it's this incredible dichotomy. So people don't want to believe inconvenient news, but they're happily carry their cell phone and use it for whatever. So we're dependent on companion electronics, but we don't like bad news. We need to communicate better. And part of this is, this field is barely 20 years old. The journal in Environmental DNA, this year is volume 8, because it only started in 2019. So it's a very, very young field. It's been evolving at a literally explosive rate. Especially in the early days, there were some inflated claims. And Matthew talked yesterday about sort of over-interpretation of results from microcosms and aquaria into the real world. So we need to be careful, and we've already got to deal with previously published snake oil. So the onus is on us, not the consumers. We need to be very clear in what this can do, what it can't. We need clear questions. Everybody who works with me has heard my collective rants about presence absence. And even in this conference, in a group of informed, educated people, there's been several people talking about presence absence. And it's like, well, you're alive or you're not. They're not the same thing. It's not even two sides of the same coin. It is non-overlapping possibilities. Presence and absence, they're each very specific questions that require entirely different sampling designs. How do you prove something's not there? Now, if you're keeping up on the literature, people are making great strides towards this. You will never prove a true absence. We have non-detections. But you can say, I'm setting this amount of power and I want this amount of statistical confidence, and with this effort, we're not finding it, so I'm inferring absence and I'm confident of my interpretation. The public does not get that. And it's up to us to bridge that gap. And I'm so going to run out of time. Whoops. So, the conference, you're all here at PISCeS. I took some liberties with the conference title. We don't need to worry about competence, at least within this community. We need to worry about the effectiveness of what we're doing. And that is bridging that gap, talking to the end users, educating the public. We cannot just provide them information. They're not reading the scientific journals. But everybody loves a good story. We're still Stone Age animals living with space age technology. Everybody is a sucker for a good story. So we need to learn how to tell effective stories. And reach into somebody else's area of understanding, their comfort zone, and then bring them into ours. No pressure, again. But part of it is being very clear. People will go for medical tests and accept the results, even when they don't like the news. We are being held to the same standards without the same public understanding. So, like I said, presence absence, that is a rant. You don't need to hear it. There was very good advice right at the beginning. This paper by Darling and Mahon from 2011, it came out within weeks of the big one, the Jurdy et al. Sounding the alarm bells about Asian carp in the Great Lakes that exploded everything onto the headlines. And I hope you've all read it. If you haven't, please do go back and read it. It's still very relevant. Because one of the things they addressed was type 1 and type 2 error. At the very beginning, it was flagged, we will have false positives. We will have false negatives. And these are both process-based, so sampling, design, etc., and methods-based. What are the chances something is there and you miss it? What's the chance you say something is there when it isn't? And this needs to be right in the front of everybody's mind when they're doing eDNA work. So that's a quarter century old. Oh no, sorry, only 15 years old. You hit a certain age, you lose track of time. It's still very, very valid. 10 years later, another paper came out flagging the same thing because the message has not got through. And part of it is our bias. We're the people generating the data, doing the lab work. We focused on that part. We're confident on our own internal lab, false positive, false negative, and what we need to do about it. This paper added to what was done before by saying, well, what's the mitigation possibilities for each of these problems? And separate it out again into lab versus field. Right at the top, inappropriate sampling method. So the very first question should be, what is our objective or our end goal, or more simply, what's the question? Presence absence is not one question, it's two, and they're radically different. You need two different sampling designs. And I will refrain from going deeper into that rant. So you need, depending on what your objective or question is, your sampling design must reflect that, or you will fail. Now, in the United States, there are already legal cases where eDNA has been used to infer species presence, block the development, or infer species absence, and it was okay to go ahead with something. Sampling design for the absence did not give sufficient power for that conclusion, but we now have a legal precedent. So you have to be careful. It has real-world consequences. It's not just reputation. So this is where we need to do the work. The eDNA community has done a lot of work on the lab component, but it has largely overlooked the whole front end. So I'm based at Trent University in Peterborough. I just wanted to give you a local example. And I work with the Ontario Federation of Anglers and Hunters, so they now get this. It's awesome. There's an annual event each spring. They stock thousands of fish into part of the Trent Severn waterway that runs through Peterborough. So it's a canal. There's a lift lock at one end of it. Fish are not jumping 20 meters. So each spring they stock thousands of fish. And there's an incentive. A number of the fish are tagged, and some of them have pretty nice rewards for if you manage to catch it. So yeah, here's Walter and Gordon. Both of those were caught this year. There's a lot of interest in this, so it gets people from the public out. You can see cars lined on either side of this canal. This is not ideal fish habitat. And there's lots of interest, and people are catching fish. Of the 40 fish with prizes attached, 23 of them were caught. 9 days of effort, hundreds if not thousands of anglers. They weren't able to give me the exact numbers. Just under half the marked fish were not caught. We know they were there. They were put in, and the derby started the next day. So what's the chance that they were not there versus they were not caught? And anglers get a fishing analogy. So for eDNA, you tell them, you go to your favorite fishing spot, you know what species you're going for. Do you catch it on the first cast? No. Does it mean it wasn't there? You fish all day. Maybe you get one, maybe you don't. Does it mean they weren't there? People who fish for muskellunge, they call them a fish of 10,000 casts. They're going fishing on faith, and sometimes they get them. So they need analogies that they can recognize and work with, and then you've got them. So we can use eDNA to infer species absence. We cannot prove it. It's an absolute. You can never get to an absolute. There's an absolute statement about absolutes. But we can use eDNA, if structuring properly for sampling design, to say we are confident that it's not there, because we would have found it if it was. And for these, I'm basically pulling up a bunch of papers I hardly recommend. I wasn't involved in any of them. But how do you prove a negative? This paper looks specifically at that and came up with an app to calculate this for you. And it's essentially occupancy modeling. What is the probability of something is there? What's sampling effort to be able to say, okay, it's a conditional probability that if it's there, I will find it. And if it's not, I will have enough effort to say that it's not. And there's a risk component. So I'd recommend this. This is one way of saying, here's the sampling effort required. And basically, how many field replicates have you taken? And then how many technical replicates or repeated tests have you done to see if it's there in the sample? This is one way of doing it. On Monday at lunch, Eric Bonk was talking about another way of doing it. There is no one way, just as there is no one set design for a study. But collectively, we have multiple options for saying, yes, I am confident that it's not there because we would have found it. This is just binomial sampling. And also, this is another one where I was wrong. Caren Helbing corrected me at the first PISCeS conference and said I was not doing enough sampling or enough technical replicates. She was right. So, and also the sampling effort is going to vary based on the size of the habitat you're sampling, its complexity, time of year you're sampling, and number one, that question. That will drive your sampling effort because that'll drive your experimental design. I'm hoping everybody has seen this figure in the top left. It's from one of the guidance documents that Fisheries and Oceans put together. And they provided to be incorporated into the first national eDNA standard that the Canadian Standards Association, well, CSA group, spearheaded. So it's right there. And it's basically, what's the question? We need to be clear, where are we sampling, what sampling effort, replicates at each stage. And I've already ranted about the presence and absence, so I won't go there. But if we want a clear answer, have a good, defensible sampling design, repeat sampling, and we can use this. So there are tools available. Here's 2 examples. I'm not going through them. What do you do with your results? This is good for the practitioner community. End users have trouble with these because they want a clear answer. They want to consult the wizard and have a clear answer. There are tools available. Each of these in the literature, highly recommend them again. So if you want to be able to say something is not there, how will you defend it? And it was great to hear yesterday's talk with the OCOM. I have some learning to do, and I think most of us do. But by the way, thank you for giving that talk yesterday. And the middle paper, it deserved the editor's choice. One challenge for occupancy modeling, you'd see all these terms. Most people you talk with have math anxiety. So you give them something like this, and they will change the topic or just go off and be singing lullabies in their head. It doesn't have to be this scary. We need to reach them. And there's a brilliant paper that just came out recently. The pizza analogy for false negatives and occupancy modeling. It's in bioscience. If I had copies, I would give them out. But that's what it actually says, bioscience. Little 4-page paper, and it brilliantly explains the idea of conditional probabilities. Olives on a pizza, are they present or not? If you get a slice, are they on the slice you got? So your field sample didn't get it even though the species are all present. And then when you do the PCR replicates, did it happen to be in the bites from that slice? So it's nested conditional probabilities that is accessible for anybody age 10 and older. So I highly recommend it. We need to be taking steps like this, finding stories that resonate with the audiences we're trying to reach. There's resources out there, things like this. The Great Lakes Fishery Commission, Margaret and I were involved in this a few years ago. First, what is eDNA? What can it do? What are its limitations? Then more recently, how do you use this information? And rather than reading this through, this is on the GLFC website, but step 2 is, what's the question? And then the next one beyond that, okay, does your sampling design and effort reflect the question? If not, do not pass go. Go back again. And it's advice for practitioners and end users. Won't work with the general public. So if we really want to make a difference, we all love doing research. Curiosity is great. But if you want it to matter, you need to communicate. And you need to communicate with non-specialists who do not understand what you're doing, but are in love with the technology and the idea. We have opportunities right now. We've lived through COVID. So for the community of practice, we have standards now. I'm a big fan of the CSA documents. We have suggestions on things to consider as you go through for both practitioners and end users. That's the static checklist compared to the flow-through one. And we have a global community that's lived through COVID, so they get sensitive testing. When I talk with people and say, I don't know this eDNA stuff, and say, yes you do, you've lived through it in the wastewater testing in your communities. So we have very little time. We have some incredibly potent tools, and we need broader uptake from the rest of society. And it's up to us to bridge that gap. So I'm going to end there, but one last thing. I'm the guy standing here. These are the people that actually have done all of this. I'm just the delivery guy. So I have a tiny, small but mighty team who've done amazing things. Or we've got dragged into this for the past 15 years, and I'm totally dependent on the rest of them for everything I've talked about today. Thank you.
Thank you, Chris. It looks like we have time for one question.
Sorry. Oh, come on, anybody can call.
At the risk of pointing out the obvious, or maybe some of the newer members in our audience, you mentioned that all of our tools are imperfect, and I would agree with that. You were a bit bullish on the use of metabar coding because of the information content. But we also have to acknowledge the imperfection of the primers that we use in metabar coding. So, I try to explain this as well. If you have 4-inch mesh, you're going to miss the little guys, right? And I think one of the challenges we see is that, at least from my perspective, when having reviewed articles, people don't actually validate the primers against the things they're looking to detect. I think that's one potential thing we may want to be talking about in the discussion.
I totally agree, and I would add on that. So most of the caveats, we're comfortable with the targeted testing. That's the easy one. You're finding one needle in a haystack, and that's it. You're conveniently blind to everything else. Metabarcoding, there's so many more complications. Because you can have primer bias, you don't know will it work, like my fish doesn't work well on sturgeons or elasmo rings. So you have primer bias. Then PCR is an inherently competitive process. So species with lots of copies in your sample, they have a preferential, they're favored. So abundant ones will be more abundant in your amplification end product. We heard about the GC bias for amplification, rare species very differently. You'll have a sampling bias from the field aspect. Stephanie and I had a poster up on how do we simplify community sampling. We picked sites with multiple depths, so we missed several species that only live in nearshore waters because we didn't sample there. So all the caveats we're aware of and have to live with for the targeted site, that's the easy one. The metabarcoding, there's layers of additional complications. And again, we need to be our own harshest critics. You pointed out yesterday, we're being held to a higher standard than virtually anything else. We're being held to a medical diagnostic standard. And we need to live up to that. So we have to be our own harshest critics. So that whatever we say, yes, it's met this bar, then we're credible. Otherwise, we're just spinning stories. And it's some of the early studies in snake oil that got published that we're now having to deal with now. So absolutely agree. I used up my time, didn't I?
So next, we're going to have a discussion panel on the uses and misuses of eDNA. So folks involved in that discussion panel, please feel free to come down and get that started.
Why don't you just briefly introduce yourself and mention one thing that you're most concerned about in terms of potential misuses?
Hi, Charlene Partridge, Annis Water Resources Institute, Grand Valley State University. I guess for us, so for those of you who may have missed it, our lab does a lot of eDNA work for identifying and targeting tiny invasive species. I guess this one is kind of at the forefront of my brain, so just because of the fact that we are trying to develop primers for new emerging invasive species that are, it's actually a multi-species complex of hybrids that have now come over. So trying to design primers in a way that are effective and cost efficient. I work with partners who don't have huge budgets. I work with land conservancy groups. I work with tribal groups. They're literally like, I have $2,000. What can we do with that? So trying to identify assays that are cheap, I won't say cheap, but are cost effective at detection, but can identify kind of like a source or multiple variants of what you're actually trying to identify. Our new emerging one is balsam woolly adelgid, and just in terms of population genetics, it's very complex. So how do we make sure that we have the ability to detect whatever variant may be coming into our area when we don't know that variant that's coming in, and then also because of the fact it's like driven by a lot of horticulture and Christmas tree farming, things are moving various places. So I think that's kind of like, because it's at the forefront of my mind with the whole detect and probability of detection, how do we even know we're using the right markers when we don't know what is actually potentially coming in?
I can be brief because you just sat through a 45-minute monologue. So Chris Wilson, biodiversity fanatic. And as you heard, the pet peeve is overinterpretation of data and misuse of good data, particularly for inferring absence without a proper experimental design. So not the lab side, the bigger context.
My name is Per Stenberg from Sweden. I'm a geneticist, and my biggest fear of the misuse is that we too soon stop training the traditional ecologists, taxonomists before we actually have the tools and the databases we need to really switch to eDNA, because we estimate that 10% of all eukaryote species just know that they exist, and out of those we have sequenced maybe, I don't know, less than 1%, probably less than, much less than that. So it's too soon to just throw away the old techniques and just go all in on this. And I see that in the students in our university, that they all want to go into eDNA, and I love eDNA, it's cool, but we have a long way to go before it can replace everything else.
Hi, I'm Karen Helbing. I am eDNA aficionado and at the University of Victoria, and I have you a captive audience very soon. For uses and misuses of eDNA, one thing that I think we don't discuss enough is sort of the dichotomy that we have to deal with having open data versus having including data governance principles within the data. And sometimes open data, like open data repository requirements, are not the appropriate thing for certain uses of eDNA.
Okay, I have a simpler one that bothers me a lot, and I almost wish I'd given a talk on this. I have a talk on this. I work in Belize, and my training, I'm an expert in Central American bat taxonomy. I've described species of bats. And if we suck bat DNA from a cave in Belize, and I blast it, I can get 90 different names. There's only 41 species that we know of. Those names are all right, but they are right in different times. So we have had 21 genus or species level changes in 10 years in one location. Now I can fix that because I know it all. I can go through and I can take out all the names that are valid in Peru but not in Belize. So there's still valid names but no longer for where I am. We've cut the species up and we've renamed it. I can fix that. But if I haven't spent 25 years figuring that out, I would say there were 90 species there. And those names are valid, they're from museum records, there's nothing that would flag them to me as being wrong. But just the fact that the records are 5 years old will inflate my species list. So we fix it, because we go through and we edit it based on what I know about the taxonomic history of each of those things. But I don't know anything about plants, or birds, or fish, or microbes, or fungi. And so when we assign names, and I don't care how you do it, last common ancestor, blast, similarity, known taxonomy, private reference lists, I don't care how you do it, no one is an expert in all of those things. So I can fix the bats, but I cannot fix anything else. And none of us can do that. And so I have a serious concern that virtually every list we have ever made is massively overinflated and not through any error of our own. Because the absolutely well-validated, published, museum-linked specimen records simply have a name from 2 years ago that you didn't know changed. And you got a perfect assignment, alignment, phylogeny, however you did it, and it generated 2 names, not 1. And I don't know how to fix that. Well, it really worries me.
Excellent all around. I think one of the challenges that we need to address that partly touches on some of these concerns is that, from my perspective, the eDNA community is largely naive to the field of biodiversity informatics. Most of us have heard of GBIF. Fewer of us have heard about some of the taxonomic nomenclatural efforts to compile common names, all of the current names and regions. It's a huge undertaking, But I think that, for me, that's a real challenge, is trying to help educate our community on some of the resources, you know, and to address Bear's point about not abandoning classical methods too soon. You know, we can also, as a community, the user community of taxonomy, help to resuscitate what I think many would see as a dying field. But we've got a lot of work to do to connect those dots. But I'm not supposed to be one of the panelists. I'm supposed to be the moderator. So I think we've heard of all of the uses. We probably don't need to go through that. You know, that's why we're all here. But I think maybe at this point, we open it up for any questions from the audience for our panelists. Okay.
I'm happy just to project, if that's okay. So I've been to a lot of meetings like this, and in my capacity, I work on a lot of projects with people, hundreds of projects a year. We analyze tens of thousands of samples. When I go to meetings like this, that we spend a lot of time thinking about tactics and procedures and responses to opportunities, but spend less time thinking about strategies, overarching strategies, right? We might say there's conventional biological diversity, it gives us an umbrella to work under. But for eDNA, we don't have a strategy at a provincial level, state level, regional, national level, continental level. And so the challenge that I would have is to get away from thinking very closely about individual tactics, experiments, things like that, and say, what would a strategy look like? Where do we want to be? How are we going to take 10,000 samples? How are we going to take 100,000 samples? How would we distribute those? What would we want to measure? Like, make sure we use things, don't misuse them. But with the experience that we have here, that's what I'd be curious to know. It's just, how would you go about doing that, putting together a strategy for the things that you want to see for diversity, biodiversity, maybe individual species, groups of species? What does that look like?
I'm going to start with this one before we give it over to the panelists, because I'm an opinionated SOB. I think one of the barriers that I see to this is policy.
No. Let me just stop you there. We always use that as an excuse, that it's somebody else's fault for not.
No. That's bullshit, because there's nobody in the room, or maybe one or two people, that actually address policy. We're disconnected from that community. So we've been using DNA barcoding since 2005 to identify individual specimens of regulated pests. We're now in 2026, and there is still not one single article of Canadian policy or law that expressly allows for the use of DNA-based methods in the management of invasive species. Not one. So, you know, this is where I talk to a lot of my students who say, you know, I want to get into conservation, and I say, we need lawyers just as much as we do molecular biologists and field ecologists. So coming back to the point about strategy, here in Canada and Ontario, the government has made statements about things like opendata.gov. We talk the talk, but we don't walk the walk, right? There has not, I mean, I think there ought to be a duty to report. So when we have environmental consultants working for primary industry to do these kinds of surveys in support of getting applications to, or permit applications approved to run your mines and pulp and paper mills and other things, that data goes into a black box. I can have a student go out and survey a dozen ponds for their master's thesis to look for Jefferson salamander. And that might end up in a paper, but the environmental consulting field working on behalf of primary industry are surveying thousands of ponds collectively every year. And I can't see that data. To me, that's a problem. And to Karen's point, we need to obfuscate sometimes the GPS coordinates, you know, to give away exact locations of endangered species, but a lack of a unified informatics approach is a big problem for us. We're generating all of this data, and yet the community who would benefit from using it can't access it. And I would love to hear you guys give your comments about overarching strategy.
Okay, yeah, actually, I want to answer this one.
I saw the gleam in your
So-
eyes.
Yeah.
Just the gun.
I agree, we do need high-level plan. And the US had a great one last year that has since been mothballed.
It wasn't that great.
It was a good start. It did not get down to the ground where you will have this sampling design where, but it was, you will incorporate eDNA to get this information across multiple federal agencies. We do not have the equivalent in Canada. If we're not going to get this by international agreement, it moves too slowly. We need individual countries and jurisdictions to buy into this and say, we are going to go ahead. We can follow broad principles. So for many countries, their endangered species legislation follows IUCN guidelines. I don't know of any that are an exact replica of the IUCN. I know in Canada it really isn't. But it's trying to follow the same principles and similar frameworks. So we can do this particularly for biodiversity monitoring. We don't need an international network for invasive species because the priorities will vary by country. So I'm answering purely from a biodiversity perspective. And I brought up this 30 by 30 example. As long as we're protecting habitat, we do not want it to be the wastelands and the garbage pits. It's what matters. So what is our contribution to biodiversity, in my case provincially or nationally or internationally? What is the importance of Canada to the world from a biodiversity perspective? There are tiny little countries with more biodiversity than we have. But what is our contribution? So we could design a sampling strategy to say we want to maximize the internal differences. We want to maximize our data diversity for sampling to contribute to the overall global GAN diversity. The Nature Conservancy actually has this for where they're looking to buy properties to set up a conservation portfolio. They look for different habitat types and they want representatives of each of these. There are models we could follow, but it will be adopted on a jurisdictional basis. And efforts like this are subject to political winds. Like the US did get a good start, it got shelved. Australia and New Zealand have a community of practice. And the Australian National Research Organization, CSIRO, is working to get representative sampling so they can say this is their national biodiversity using eDNA, and that is then guiding bioprospecting and specific sampling for DNA barcoding. With metabarcoding, we can identify species we don't know what they are, but we have novel OTUs or bins. And say, there's something there, we don't know what it is, we should go find out. So we will not have an international, yes, we're all going to join up together and shoulder to shoulder, we're going to sort this out. And we can't get there from here, but we can do it on a jurisdictional basis. We need a few people to lead the charge for other people to follow.
Sweden's doing an impressive job already.
Just like sort of one sort of ancillary thing about this big discussion, and that is like communicating in a common way what the eDNA data are in the first place, including the metadata. There are many different ways that people are recording the metadata, if at all, and how they're curating the data and using the data. So there's a global effort towards harmonizing that. That recently was published. The charge was led by somebody from Cicero, Miwa Takahashi, and it's a FAIRY eDNA suite that allows for like a harmonized way of using field codes and things like that to look at metadata and the actual data of both metabarcoding as well as targeted assays that has like global buy-in. And I think that is key to any of like these large-scale initiatives, because otherwise they get swallowed up and nobody can actually use them because they're not fair. So anyways, I have a slide on that I will share with you soon.
I just want to make one comment. This is definitely not my area of expertise, but I think in theory we could design excellent surveillance systems for all sorts of purposes, but we're not really there yet to exactly define how that would be. And we're going to discuss that for another decade, and then we're going to set it up, and then we're going to have to wait for another 2 decades before we get enough data from it to do actually think something about it. And that's just going to be too late. That's my gut feeling. I think we should put more effort into identifying the samples that are already there. I heard a couple of weeks ago about, that was from Sweden, I don't know where it might exist elsewhere also, but they have stored sediment samples from all across the Baltic, which is the sea around Sweden, from 100 years, every year samples. Someone should look at that. We have a spore trap system in 300 locations across Sweden where people look for spores of fungi that harm the trees in Sweden. Those samples are there. Someone should look at that. I mean, there's just tons of things out there that I think we should go investigate because we need the data now, not in 10 or 20 years, because then it's too late.
I want to come back to Karen's point and make this interactive for the audience. How many of you know what a semantic ontology is? A semantic ontology? This is how we actually define fields in our metadata. So this is a value, say coordinates, and then the elements of that would be how you record, is it degrees, minutes, seconds, So basically you develop a semantic ontology for this kind of data reporting. And this is an example of us being totally disconnected from the biodiversity informatics community. There is a whole community that's been working for decades called the Biological Collections Ontology. They've done this work. We don't even know about it, so we continue to report our data as a dog's breakfast. So to your question about strategy, I think it has to be more inclusive. But if you don't even know what an ontology is, you don't even know the question to ask, right? So that's part of the goal of this forum, is to help educate people on where the gaps are.
And just to kind of add on top of that, I'm a big fan of the fairy DNA checklist. Is that GBIF, OBON, like major biodiversity agencies have all bought into and contributed to this checklist. So like it really deals with all those semantic ontologies, I use the big words, and in a very effective way that's cohesive with the already existing very valuable databases out there.
Indeed.
I wanted to come back to the question about, do we have a strategy? And at least within the FO, we have a strategy. We built it for 2 years since 2021, and it lasts for 2 years where we sat scientists thinking, the eDNA scientists, but also all of the rest of scientists from the FO, they saying like, it's going to come to us. Like there's going to be a flow of requests for eDNA testing in Canada, and we need to be prepared. But we're living in governments, having different views, and sometimes someone can come in and just drop the strategy you wrote and accept it. And so that's what happened. So we don't have any more strategy, and this government seems to be able to push things forward if industry are asking for services or for laws or for different things to move forward. So when people were talking about the problem that eDNA was not recognized for species of concern or species at risk, if companies are saying that's an issue, you want eDNA to be acknowledged as something to be used, then we can work and make that work so that we think all together of how this could be robust and how that could move forward and be used by COSE, for instance. But we need push from companies. This is the only way I saw that things can move forward. And I also want to talk to you about another example where eDNA was used in court by the Canadian government to show that in mothballs. I don't know if you know about that. So mothball would be imported with zebra mussel in it. And in some cases, it was only larvae, and we couldn't see it with microscope. And so eDNA was used as a proof by lawyers to say there shouldn't be even DNA of invasive species within mothball. And so people that were importing the mothball got fees, or sorry, I don't know in English, but they got condemned to pay an amount of money. So that was the first example where eDNA was used in a kind of regulatory context. So it's getting there slowly.
That's excellent to hear.
Maybe this is naive because I don't work in policy, but I think the problem is that the top-down policies are the ones that don't work. Because they either have no actual science behind them, there's many of those, good ideas without any practicality, or practicality without any way to enforce them, is usually the problem. But I think, just from listening, I mean, you are in the Government Policy Institute and you're doing this. It didn't require a federal law for you to use the tool. There's a huge number of people who are in the regulatory and policy industry using these tools without the requirement of a top-down law to enforce it. And there are a few places where they have done the top-down law component, like the UK, and it didn't work because they did it a little too fast without thinking it through. It caused more problems than it needed to. I spent 12 years in the UK with those problems being ones that came up over and over again. I'm not sure you need a top-down policy to make it useful. What you need is a whole lot of users who happen to be in policy. And then it goes bottom-up. Use the ecology reference, bottom-up rather than top-down. And I think if it just becomes so common, and it is, that everybody in these industries is using it, and we have commercial industries, we have businesses, we have regulators who are using it, it just becomes part of the toolkit without it being imposed on you. I think it's the imposition that's the problem.
I definitely agree that that's a big part of it. I also think, though, without some sort of framework, strategy, laws, however you want to put it together, we continue to build a tower of Babel. So the MyFish primers don't work great on all the freshwater fishes of Canada, but that's the dominant tool that everybody goes to. We have different ways of assembly, different reference libraries, and we're never going to standardize and harmonize all of it. If we're not getting together in a forum like this to discuss it, and at least push for it, then I think the bottom-up approach risks just being chaos, and then having the baby thrown out with the bathwater in a legal system that's based on a series of precedents. And that's kind of the territory we were straying into with the CAR.
You could see a lead in there. Just one thing on this. One thing I think that is helping us move forward on this is where the CSA group pulled a group of people together and said, can we agree on data reporting standards? So the two that are out there now, one for environmental DNA in general, and a follow-up for targeted qPCR. So if you haven't seen these, I encourage you to have a look. But it's essentially saying, these are the things you will report. So to be considered credible, there are elements that you must report at each stage. Or you're not reliable, you're not credible. And then there are at each stage, here's the things that you should do, but it's not mandatory. And then there's a third one saying, well, you've got some creativity, you want to pursue something else, that's great. So it's worded as you shall, you should, you may. Those took years to pull together. Because we do start, it was very much bottom up for each of these, and it is a bit of a tower of Babel, I will admit. But we actually got there. These are not final endpoints, and they will be revisited periodically. But we need a common language and a common currency. It doesn't mean we have to lock in that thou shalt use this assay, or this is the one and the only pipeline that is credible. But we need a common frame of reference and standards so that if I do some work, Caren won't scold me necessarily, because I hopefully had it right in the first place. But we need effective communication to get away from the Tower of Babel and have one consistent framework that we can then all operate.
And I'll just add to that, I think because aquatic eDNA has matured a lot, it's a lot more mature than maybe airborne eDNA. Yeah, there's a flood of it, and primers have been tested, and you have a decent idea of which primers work well for which groups. And I think in the airborne DNA world, we don't know that yet. Like, raise your hand if you've done plant genetics. Raise your hand if you've done conifer plant genetics. Like, there's not a barcode for plants. Like, there just isn't. So different genes work better for different groups. I had to put 3 genes together just to make a phylogenetic tree for one genus, right, before I could identify this family. So I think for the airborne DNA world, I do think we have a lot of work to do to try to figure out if we're doing shotgun sequencing, maybe it's a little bit different, but especially with amplicon sequencing for arthropods, especially arthropods and plants, because we know the common primers that are out there are not covering a significant proportion of what we're actually giving. I mean, you can look, I can tell you from my data, we never caught mosquito DNA. I work in riparian systems in Michigan. There, I can count the mosquito bites to tell you what the biomass of mosquitoes are there. So the primers obviously aren't working great on that. So I do think, at least for the airborne DNA world, we need a little bit more information just about how primers are working across different groups, especially if we're going to start looking at plant communities, because that plant genomes are a mess. Yeah.
Thank you. So I do work with plants. I know everything you're talking about. And so I just wanted to make 2 points. I work for CFIA. So yeah, government is a bit of a mess. Bureaucracy is real, always. And so while I agree with both points, like policy needs to be established to some degree, and a strategy it's necessary. But I'll give 2 examples on things that have happened to me. One of them being, I did a lot of work with Amaranthus palmerae, which is a very bad invasive plant, where one plant can produce 1 million seeds, right? And it's regulated like in 13 states in the US. It hasn't been regulated here, even though we know it's a big threat to major crops in Canada. And it's been, I work with the people that try to put out the documents to regulate it, and they have been doing this for years. Everyone in the community, every time that we go to CWSS, Canadian Wheat Science Society, 50% of the talks talk about this plant. And everyone's concerned, parks, everyone's concerned. And we haven't been able to regulate it because of bureaucracy, and there's a list of plans, and there's not enough people, and there's micromanagement in every single step. So it becomes really complicated to push like a general policy and rules. And so while I think those are necessary, and I don't know what the answer for this is, it just takes a long time to establish policy to regulate like a single plant. This single plant that we all know is bad. Like, we have proof in how it decreased crop productivity in the States by 70% in soybean and cotton and all these plants, and we can't still do it. Now the other side, which is also largely bureaucratic, is that we wrote with some colleagues an SOP for the International Plant Protection Convention. And this is work from like a decade for identifying Amaranthus palmerae. And we have protein methodologies included in that protocol. We have DNA barcoding. We have AI identification of seeds. There's like 5 different protocols to make a single SOP to establish something that the international community can use. So there's a lot of work in establishing something that's highly validated and that most of the community internationally believe on. And so I don't know if we should find like a halfway, but one thing that I think, looking at eDNA, is that like we have a long way to go in terms of getting there, because we work with seeds, we can see them. And so we work with plants and we can see them, and there's different ways of validating. But as you guys said before, once you characterize eDNA, many times we don't have a sample to back it off, right? So there's databases and there's stuff, but I don't know, people tend to believe what they can actually see, and we work with things that we cannot see. We produce data from those. Again, I don't know what the strategy is, but I know from the government side what the status is and how things work in government, at least here in Canada. So, I don't know, food for thought, I guess.
I think it kind of illustrates in the point that Beth made about maybe we don't need as much top-down approach, or we still need it. It's going to take a while to be formalized. But Genevieve made the point about working closely with industry. I think that's key. We don't necessarily need government policy in place if the industry adopts this. You know, and to your point there, Beth, about taxonomy and lack of taxonomy, it is highlighted, you know, some of these kinds of partnerships that are already coming up. The one we heard about yesterday from UML, working in collaboration with EcoReg, who's working with primary industry, who's already sending all of their specimens off for expert taxonomic ID. And they do this all the time. Why aren't we barcoding that material? Well, now we are, thanks to that partnership with industry. So I think that may be one way forward, is to be working directly with our user community more when we have that opportunity. Anybody want to comment on that?
Hi. I guess I wanted to riff off of that a little bit. As a consultant, I do deal with a lot of industries, and I promote eDNA every place I can. And I guess I've noticed three sort of themes emerging from the different industries. There are some that, I think eDNA would be great, especially for baseline studies, before they go and build something. But the common feedback I get is, well, we don't have to. So why would we do that? Like, it's not part of the regulations. We're not going to spend the money to do this if in the end we submit a report and it's not really accepted and we still have to go through all this other stuff to do it. So it's ultimately rejected. We do have some other clients who are very open and progressive, but some of those have been burned previously with eDNA studies that were not of adequate quality. And so I've put these cool projects together, these proposals, and they go, nah, eDNA didn't work for us. Like as a blanket statement, right? Like eDNA doesn't work. And so I think going a little bit with what Chris was saying before, but we really need to get this idea out there that eDNA can do all these great things. Because they had that one experience, and now they don't want to do all of eDNA. So how do we get it into the public eye, into industry, that eDNA is fantastic? Like, how do we get all of these good stories out there to the public? To us, that's one thing. To the public, to the industry, how we need a way to have a platform to get these ideas out there. One place, like I guess a good story of progressing eDNA is in the Yukon. So I just got a proposal accepted there because they know my stuff from Arctic grayling, and they've got 4 people to monitor all of the Yukon. And it's obviously not, a very easy thing. There are a lot of environmental issues there right now, so it's very important. And so they need a way. They've got all of these communities coming that they want to employ eDNA, and they have no way of looking at these proposals and saying, yeah, that's a good eDNA assay, or that's a good framework. And so I'm going to help guide them in how to say that, that's a sufficient methodology or whatever. But that's one place where they are fully ready and accepting and need eDNA to help supplement their 4 people up there to do the rest of the work. So I don't know if there's really a question in that, but I guess it's more of a overall, like overarching, how I've seen, and I don't know if I speak for all consultants here, but what my interpretation is of how it's been dealing with industry.
I think that's a really good point about, you know, the role for some level of top down too, because we've seen similar things, where, you know, people are saying, yeah, well, the government isn't making me do it, so why should I pay for it? And as you said, there are more forward-thinking groups in industry that are willing to explore the technology. But I think one of the things that you've clicked into my mind, coming back to Genevieve's point about industry, there is an emerging industry of laboratory service providers, and we'll hear more about a perspective on, you know, the kinds of things you should look for in a lab in the workshop later this afternoon. But maybe that's a neglected part of the industry that we haven't been working as closely with. I think Karen's going to tell us a lot about what the iTrack project did to help further this. But yeah, you know, if we have different quality service providers out there that risk having, you know, some of this stuff thrown out in court, or at the very least souring people on participation, that is a problem.
I have to be really careful how I word this. There's a couple of us in the audience, including me, where I'm an editor at Environmental DNA Journal. And then I'm an editor at several journals. And I think one of the things about credibility that we need to worry about is that there's still a huge amount of really bad science being done amongst people who should know what they're doing. So if we're trying to get this moved up into accepted regulatory policy, we need to be a bit more careful. I still get a manuscript every week with no controls of any sort. No lab controls, no PCR controls, nothing. That still is being published in places. We still get manuscripts continuously where we just used every default in my favorite pipeline without thinking about what gene or what species or what taxa or what region or whatever we're doing. And some of those defaults, I've been in this business now for almost 30 years, one of those defaults was invented by my husband. I know what it's from. And I get people writing back and saying, you have no idea about this. No, I do because we invented it. Some of those defaults come from very archaic 80s presets in things that have been incorporated into programs and shouldn't have been, but it's a default. So some of these things are problems that are cropping up in data and they're creating issues. But we have a second issue as a community. And this is my anecdotal observation where we can all actually participate in this better. The eDNA community, as far as I can tell, are the worst reviewers I have found. And I don't know how the other editors in the room feel about this. So I edit multiple journals. Biological invasions, if I send out 6 requests, I get 3 acceptances. eDNA, 26, 0. We are a terrible community at agreeing to review stuff. And in the people that accept review requests of these papers, I would say 10% of them write back, good paper, you should publish it. Which wasted a month of time. The review request, the waiting for the response, and I can't use it. And we also have an interesting problem in this community. A huge number of people have blocked the systems that request review. I get bounce back emails because people have blocked Manuscript Central and those platforms. So they're not even getting the requests. If we want to improve the reliability and the acceptance and the quality of what's out there, those of us who know what we're doing, you should review at twice the number of papers you submit. That's your basic requirement, because if I get 2 reviewers from you, you should review 2 in response. No one does that. I have one friend who does that as a policy. For every review you got, you have to do 1 in response to just meet the requirements of the field. But we are one of the worst communities for this. I don't get it. And people write to us all the time saying, why has it taken 6 months to get a reviewer for my paper? The answer is, I'm on reviewer invitation number 27. So please, if you are participating in this science, participate in both sides. So review papers, look for the classic errors. Controls, did you use them? Did you have them? And tell us. Don't just write, that's a nice paper, because we can't use it and it just wasted everybody's time. So I think if we want credibility and we want this to move further, we as a community have to do better with the science part of it. And this has been, I've been an editor there for a couple of years, you've been there longer than I have, I don't know how long you've been there, Genevieve, but this is a problem, and we get together as editors and say, what are we gonna do? We actually had someone suggest that the editors become the reviewers of the paper, which I think is like a terrible idea. But, you know, if I'm having that problem when you send me a paper and then you get mad at me for not doing it fast enough, we send a request out every day, and they just get, my favorite is getting blocked. And I took to social media once and I put a rant on Twitter when it was still Twitter, and I think Blue Sky, saying, how can this community block the manuscript request reviews? That one I think is insulting. People who submit their papers, they want them published, but block the emails and request reviewing results. My postdoc was the #2 reviewer for eDNA last year. Did 10 reviews for the journal. That was the top reviewer, I think. We got the list back. I couldn't believe she'd read them all. But we got to do better.
Well put.
I mean, this might be going off topic a bit, but I think that kind of highlights maybe an issue with the scientific process as a whole, because as a younger person emerging in science, I have, I think, good review skills, but I was never explicitly taught how to properly review a paper. So I had an advisor who was very big on making edits. I learned a lot from him, so I think I am considered a decent writer, but a lot of people don't have that experience. So how is one supposed to know how to review a paper properly if we're never taught how to do that? And the other thing that I think is an issue is incentive, because as human beings, we're kind of asked to basically have this scientific integrity and basically just review out of the goodness of our hearts. And we are in an economically difficult time right now. And young people especially are working 2 or 3 jobs to try and survive. So if I get asked to review a manuscript, I don't have the time to do that. And I also don't have the time to do that in a way that would be good, because I'm not getting paid for it. So why would I do that? And that's not an issue in the eDNA community. I think that's just an issue with the scientific process as a whole. But I think, unfortunately, as human beings, we operate much better when we have some sort of incentive. And the incentive to have science be good and do a good job is, I think, something that we all want. But I think considering the current economical situation we're in, it might not be enough.
And that's a fair point. I mean, from Calvin's workshop, we saw that, pick on Elsevier for a moment, I think was the one we showed, that was more profitable than the big tech companies. I mean, what a good deal for them. We write the papers for free, we review them for free, and then they charge, $5,000 to $10,000 page charges if you want an open access. So maybe some sort of a financial incentive would be an appropriate model here in terms of getting reviewer acceptance, because we are going to do a special collection from this conference. And I've got all of the registrants' emails in my system now. We'll be calling on this community to serve as model citizens, and let's hope we can do better. Margaret?
Yeah, this is definitely something that I find as an editor too, and so I would say, first of all, if people aren't authors themselves, then I think then that you are a little bit more given a pass if you decline, because you just don't have the time. I know that when I send out reviewer requests, if it's people who work for a consulting company or something where that they don't have that 20% service in there as part of their paid job, I understand that is going to be something they may not be able to do. Although if they're an author wanting others to review for them, then that's the incentive, that's the quid pro quo. I know that there are some reviewers who don't publish in the journal that I'm editor for, and so it's reasonable that they may put their efforts to their community. But yeah, that if there are authors who are wondering why it's taking so long to review their manuscript and they've just declined a reviewer invitation, I'm a little bit less sympathetic. But the other thing, if I can go back even one step further, one thing I'm really finding frustrating is manuscripts that have a large number of authors on it. I wish some of those authors had put more time into reviewing the manuscript before it was submitted. I see this a lot, particularly with papers where a student or a recent graduate is the senior author, the first author. I want to be very sympathetic. The reviewers want to be very sympathetic and encouraging for the students, but I see 3 or 4 big names on the paper and they're getting credit as an author, the volunteer reviewers aren't. And so I really encourage those more junior authors to take full advantage of their author list.
I don't want to hijack us into a peer review discussion. I have a whole lecture on this in my research methods class, which I'm happy to give sometime. What I really meant was that if we want this to be uptaken as policy, if we want to get to those big things, we need credibility. And credibility in science still comes from what you produce. And that becomes a reflection on us as a community. And as a community, I worry about some of our credibility at the moment. And that's unfortunately the currency we still work in. So I think, if you want, we're talking about papers that got through in the early days that wouldn't now, shouldn't have then. The only way we correct that is by producing better science now, that we can point to and say, well, that was old, this is new. And I think that gives us credibility for policy. The UK model is interesting, where they actually track whether or not publications you do get translated into policy. That's something they should get measured by in the UK. It's an interesting system, but they quantify that. So there's that production of good science, to a certain extent, is what gives us credibility to ask for policy. But we as a community are in control of that. That's the one thing we can control. And so that, it starts with agreeing to review a paper and doing a good job of it. And I totally agree with you. Remember, the editors aren't paid either.
I had a question. Don't mean to keep on harping on the whole peer review issue, but I guess one of the questions I would have is, how do you find people to review? Because I've never been asked to review.
Can I have your name?
I mean, in this room have been asked to review an eDNA paper from eDNA journal. Haven't been asked. So most of us, so I'm wondering, how do you, without personally going to all these journals saying, I'm going to be a reviewer for this journal, how do you, like I was at the last PISCeS meeting, and so there was a database that has me on there somewhere that I was interested in eDNA. Like, I've never written a paper on genome skimming, but I've been asked, somehow they figured out that I'm interested in genome skimming. I've been asked to review papers on that as well. So I guess what I'm wondering is, how do we expand the the reviewers, potential reviewers.
I'm going to yell to you. I think editors, I think editors have 3 strategies. Journal systems suggest reviewers to us by keywords that they're registered in systems. So if you're in a system, you're going to come up eventually by the keywords you put in. That's number 1. Number 2, I go to Google Scholar, and I type in the keywords of the paper I'm trying to review and find out who published in that field in the last 2 years. I don't look for someone who published it in the 90s, because the methods will change. Those are my 2 methods. And then you go ask your friends when that fails. Can you please review this paper? I don't know.
It would be nice to have.
Matt, anything different you do?
No, I look at the topic of the paper, I put it into Google, I see who's published what, and then I start asking.
The theory being that if you've recently published in the field, you know the sort of things that we're looking for as criticisms that you'll look for, and that's my theory. On the other hand, I absolutely love the idea of getting hold of the entire conference list and handing it up to the editors. You may regret suggesting that, but I'll take your name at the end.
I have a question. I want to back to the primers, since I'm from the lab. So what I have been observing, we know we need different primers, different targets, that's fine. However, we often follow because somebody else already published the primers. So let's use it. And once, twice, 10 times, then become a golden standard. So then we stuck with it because everybody else's data is using that primers. But when you work with the primers, you know the primers have issues, and you already know. So I wonder if as a community of eDNA can maybe come up with a work group. We need to fix those first, and not just by one postdoc to have the literature review to summarize all the primers used and all the papers published, but needed to turn the primers upside down. Do we have the right ones, or that's what we want to use? And then give some choices. Of course, the researchers are free to move on, to be creative, create the different regions, different primers. But I have a problem with we stuck with something look-alike, and further and further, if we stuck at 20 years, and it's too late, because if we have the data, you can go back to analyze it. But if we use the wrong primers at the very beginning, we miss a lot of information. So that's my question or comment.
Those are amazing comments. Thank you. First principles, things are going to change as people use tools. They'll learn more about what the advantages, the strengths, and the weaknesses of those tools are. And it's really, really important that that we as a community do our best to have appropriate metadata that are associated with the tools that are being used. Importantly, performance characteristics, controls, things like that are like key in terms of interpreting the results, and that those bits of information are not hidden. I mean, how many of us use metabar coding data and we just filter out human, right? Or anything that isn't, attributed to some classifiable ASC. So, so those types of things could be very useful to actually have, reported in studies and so on, because as we learn more, we actually can, use those data. But this is also the importance of using things like the FAIR eDNA checklist, but also using appropriate standards and best practices and guidelines, depending on what's available for the various tools that we're using. And can't say enough about the two Canadian standards that we have as a community created, and we wish to create more that deal with those types of things. And a key thing is to actually be focusing on performance, not on a particular primer set or targeted assay or anything, but really about performance and what you need in order to be confident about the data that you're producing.
I would agree with all of that, and also say we are, of course, dealing with a moving target. We've been shackled largely to that 650 base pairs of the 5' end of the CO1 gene, because that's where the barcode of life started. But that turns out to not necessarily be the best gene region for developing primers for eDNA, whether it's targeted or metabar coding. So these efforts to extend to whole mitochondrial genomes and genome skimming are going to give us a lot more options. Organizing some of that information about primers through the GenFish project, one of the things we tried to do was build a big alignment. It's hard to know the veracity of a primer set when we don't know what you used as an alignment to create it in the first place. So, there are a lot of things that can be done to improve on where we're at right now. And to your point about a strategy earlier, maybe that is a place for self-policing the community so that we do better, is having a registry of some of these things. And as reviewers, adhering to those FAIR principles. I think we've heard a lot of really interesting points, and maybe we have time for one last question.
Yeah, thank you. Everything's very interesting. I just want to call the attention to something that has not been touched and that is capacity building at the international level. Because we want, for example, agencies to take eDNA as a way of evaluating diversity, but for that we need to improve the quality of the research, right? And that cannot be done by Canada alone or Australia alone. This needs to be extended to the whole world. And for that we need extensive ways of capacity building of many scientists that are eager to improve their monitoring of their countries or their local habitats. And I think that we get as well to improve that, we will have like more dice, no? The probabilities, at the same time the probabilities will increase of getting some agencies to take this into account, for example. So I think that as a community here, we need to think as well of capacity building at the international level. Thank you.
Excellent. Well, closing remarks from the panel.
I totally agree with you, because we also work together, so I agree with you. I would draw I would draw one interesting point about that I think reflects it. If you caught it yesterday when Lauren was talking about ethics at the beginning, the people with the highest ethical concern were the people who are not working in the country where they live. And I think that's reflected in that. The idea that many of us work in countries where we're not residents, and we want to have better collaborative opportunities so that they're I think that horrible phrase, knowledge co-creation moments, where we end up with proper exchange systems. And I think that's where that connection was happening, is that's what should be happening. That level of capacity building and partnership should be a universal constant.
Go ahead and pass it back, let everybody have in closing remarks on the session if you like. If not, that's fine.
I've got my own time in a few seconds.
Yeah.
Well, maybe a short comment. I think we also need to think about different tools for different purposes. I mean, metabar coding and shotgun, whatever, is good for some things, but for a lot of the needs I see about, let's say, invasive species, I talked a few weeks ago to a woman who tries to monitor in harbors in Sweden for an invasive fish. Maybe not the traditional eDNA methods should be used there or thought about there, because it's just going to take too much time and be too expensive, because they need to get thousands of samples every day, basically. So maybe why not we not put the effort into all these technologies that are common in my other line of work, where we work with military or point of contact and medicine. They need quick answers, and then maybe a LAMP or a Sherlock or a lateral flow assay would be the better option, because it's cheap, you can mass produce them, and you get the mixture too, you get the color actions quickly. So I think we need to carefully think about which tools are good for what.
Oh, I have something to say about that. Actually, know your tools. Know what you're working with and pick the best tools for your question, because every single tool has its limitations and its strengths. Know your tools.
And pile on that last one as well, yeah. Based on what's the question, pick the right tool for the question. I basically wanted to touch on the last point, and unfortunately she just sat there. But we need to make this technology and this information available. I harped on about biodiversity earlier, and Canada doesn't have much biodiversity on a global scale. We have a lot of space, but we've got some of the youngest habitats in the world on the oldest geology. There's tiny little countries elsewhere that have far more biodiversity than we do. Papua New Guinea is an order of magnitude compared to all of Canada. We have this standard of living, this level of education, and access to all of this technology, and we need to make it globally available. And this isn't just Canada. All the G7 nations have the standard of living. We can afford to make this available. And the information needs and the enthusiasm are with the people who don't have these same luxuries. So where we can make the biggest difference is getting out there and empower them. It's fun to do this stuff. It's great to satisfy your curiosity. As a scientist, you never have to grow up. But as a person, the ethical responsibility is be an adult, help the people that need this the most. And the best way to do this is not go there and tell them what they've got, it's empower them. My favorite poster last night was on a high school project, where the high school kids went out, did benthic sampling for invertebrates, put them in a bucket, I hope you guys all saw this, and I'm just repeating what you already know. That was grabbing the young minds before they get old and stodgy like us, and getting them excited, and they got that understanding, and that teacher changed those kids' lives. And we have an opportunity and some responsibility to do this for the rest of the planet. No pressure.
I guess my takeaway is be careful of the oh shiny method. So I consider that oh shiny is anytime a new emerging technology comes out, we look at it and we go, oh shiny, and we all want to adopt it. And we all think it's going to be the best thing that's ever happened in the world, and it's going to change everything, and now everything's going to be better because we have this oh shiny method. Be skeptical of the oh shiny. Be skeptical of your data. Anytime you get a result, assume you've messed up until you've proven that you haven't messed up. So I guess that is my word of warning, is that don't be blinded by how cool the technology is. Assume it's wrong every single time until you've shown that it's probably not wrong, but it could still possibly be wrong.
Agreed on all fronts. Let's have a round of applause for
Now we're going to hear from Dr. Caren Helbing from the University of Victoria, who's the second keynote speaker today.
Thanks, Matt. First of all, I'd like to thank Bob and Beth for inviting me, and Matt, I guess the committee, for inviting me to give a talk. But I'd also like to give a round of applause to them for this amazing meeting. So first of all, I'd like to acknowledge that I live, work, and play on the territory of the Esquimalt, Kisepson, and Wasanich peoples, whose relationship to the land and water remain to this day. As an academic, I've had the pleasure of working with a number of First Nations communities and have wonderful interactions and really cool projects and stuff. And I'm humbled by how much I have left to learn. And I have the 6 R's up here in recognition of the 4. As I decided to put the 6 in there rather than the 4 that Kat mentioned. As a reminder that this is a really good way, or to honor those things in my daily life, but also in learning how to do science in a good way also. And I also would like to thank Kat and Gary for their insights and sharing those insights during the conference. So I'm a co-lead on the iTrackDNA project with Valérie Lenoir at INRS and also Jérôme Dupois from UCAT. This iTrackDNA project is a Genome Canada, Genome Quebec, and Genome BC funded project, large-scale applied research project. And it's been going on for a bit over 4 years now. And the project itself, the goal of the project was to basically raise end user capacity and proficiency in the use of eDNA methods. And we went the easy route. Where's Chris? Oh, there's Chris. We went the easy route because we decided to focus our attention on targeted qPCR-based assays. And that was definitely a strategic move because we felt that there were definitely things that needed to be addressed on the eDNA front before things went all crazy out of hand and people were using things in very wild and crazy wrong ways, and basically overshadowing the transformative potential of eDNA. And in this project, we really aim to fill a number of gaps, critical knowledge gaps, and also just sort of procedural gaps and things like that, that are essential for confident uptake. And I've got it broken down here into 4 segments for the project: robust assay and study design, genomics resources, promoting national standards creation, and then also developing frameworks for training and proficiency testing. Now this project is what I'm going to be doing over the next few minutes is giving you some highlights of some of the accomplishments that have been made in the iTrack-DNA project, and some challenges and so on that we still face. But I want to, at this point, acknowledge that this is work that was done by literally us and 50+ partners that are shown in the diagram there. It's been amazing to working, several of you are in the room, and it's been an absolute pleasure and amazing to work with all of you on this. So I'm going to break my talk into 3 segments. One is looking at how we actually identified spots along the eDNA workflow that would be like pinch points, and how to actually get around some of those pinch points that reduce the effectiveness of eDNA assays. And then also, since there are multiple approaches to measuring eDNA and stuff like that, even within the realm of targeted assays, how can we ensure that labs meet like a minimum acceptable competency level and that? And then finally, I'm going to talk about translating data to action. And we have lots of data, but what do we do with it? And how do we work with it in an effective way? And we've already had discussions around this, so I'll just expand on those. Okay, so first one, confidence in tools. So a large part of the iTrack project was actually focusing on building robust qPCR assays, because there are some really crappy ones out there, and that's just a fact. And so using like fundamental principles of biochemistry and molecular biology, that helped us to identify some key pinch points along this workflow and address them head on. And I hope to convince you that those tweaks have been good tweaks, and that people can actually apply these to whatever you need to. So what's behind me here is the workflow, and so you have to identify what species you're interested in, and also importantly, what kinds of confounding taxa might challenge your assay for working well. And then once you've identified those, you have to collect the sequences for those, and identify regions that might be good for primer and probe design. In the case of qPCR-based assays, primers are not enough. You need to have primers and a probe in order to be able to have confident use of that technology. Then you design those things using hopefully like great design parameters and stuff like that, come up with a great design, and then you validate it using synthetic double-stranded DNA like G-blocks or something, and also on voucher specimens, checking for specificity and stuff. And then when everything is all said and done, you've developed your LODs, LOQs, and all that kind of stuff, and you're like wowed by your amazing assay, then you bring it out to the field and you field validate it. And that's kind of like along the lines of Bettina Thalinger's ranking system of, you know, having maximally validated assays. So we applied this and again identified some things along the way and tweaked them, and have come up with 125 plus validated qPCR targeted assays that are relevant to species in North America. So this has been published, and all the assays are the details and everything are published. But I just wanted to kind of stress the tweaks that we made, and this paper actually describes in detail, you know, all the considerations along the workflow here. But the LODs and LOQs that we were able to achieve, so our median LOD is 0.4 copies per reaction, and our LOQ median was 1.7. Relative to the CSA standard for qPCR performance criteria, we did a good job. And we're very, very pleased by that. And each assay, when you use an assay, should be always described by these fundamental performance criteria as a starting point, but not as an end point. So to help describe what assay you're using. Now, one of the challenges that we faced in starting this, so I showed you sort of the end result, but in getting there is having enough genomic resources in order to build really good assays that have amazing performance. And one of the key things that I think we all acknowledge is that, you know, CO1 represents 4% of the entire mitochondrial genome and has been sort of the starting point for many, many people's assay designs. And it's kind of putting a square peg into a round hole in terms of forcing, yes, you may have specificity in terms of the sequence, but when you then actually go to design a targeted qPCR assay, you suddenly are faced with challenges such as repeated sequence. You have primer dimers happening. You have a whole bunch of things that are not conducive to a well-performing qPCR assay. So we took a different approach and said, well, hey, you know what? Why do we have to limit ourselves to CO1 or whatever small metabar code is available on GenBank or whatever that we have at our fingertips? Let's go for the whole mitogenome. So part of the iTrack project was to actually develop a way to effectively get at mitogenomes and augment the current complement of full mitogenomes that are available, from which we then can actually design assays to. So this slide is a summary of a ton of work and represents the workflow for generating mitogenome resources, but then also funneling those resources into targeted assay design. And it highlights not only the path along the way, so you're starting off with, you know, some experts saying this is a voucher specimen for species X, and you get a sample of it. Sometimes it's like, wow, it's like a bit of tissue and you can isolate it really easily and stuff. Or it could be a portion of a shaft of a bird feather, or it could be leather that has been sitting in the museum for who knows how long. Any of those can actually work as long as the key thing is that as long as the voucher is there. Like so you're confident about what the ID is of that specimen. So the first thing that we tried to work with was figuring out, okay, like it's really hard to get voucher specimens, especially for endangered species and so on. But if we can get our hand on like anything, you know, like roadkill, anything, you know, can we make this work? And so a big problem is often how much DNA you can get out of your sample. And so it turns out that you can actually take like literally a 15th amount, that is a scientific term, I'm sure of it, of DNA, and amplify that with a special enzyme that can actually amplify a mixture of DNA truly. And it's been used by museum curators and stuff in the past, like a SciX kind of enzyme, and enrich that. So augment what's in there faithfully to the point where you can actually do whole genome shotgun sequencing on that, and get a representative sample from leather or bird shaft, crazy things, and assemble a full mitochondrial genome from it. So the GoEnrich procedure describes how to amplify your sample to do this. And then MTGrasp is a gene skimming utility that allows you, without using a ton of resources, like compute resources and stuff, you can do it on your laptop, your ancient Mac or whatever, or Apple product or whatnot, and generate full mitochondrial sequences. And the bonus is that MTGrasp also standardizes how the output looks. So we've actually done an extensive comparison using the next utility called UniqueSeq to actually identify regions that are common to all mitogenomes, and declared that as being the starting point for a linear representation of the mitochondrial genome. And we also standardize which of the two strands, so the heavy strand, is actually represented in the final output. So that standardization is really critical because the next steps are, like, you want to do alignments and things like that. You know, if you have the reverse and complement, well, aligning is really hard, right? If you're starting in different starting points from a circular genome, that makes it also hard, and so on. So we've actually built that into our gene skimming technique. Then this UniqueSeq is actually turning out to be a very versatile utility, in that UniqueSeq can align what you designate as your in-group, and then identify unique regions that you can then, like against literally thousands of sequences, full mitogenome sequences, and identify those unique regions that you can then focus in on in an agnostic way, that you can start designing your assay to. And then finally, we use EloQuant, which is a methodology for generating low copy number derived LODs and LOQs. So, how many? Okay, this is an audience participation thing. So we talked about, okay, Cohen is not, sufficient for lots of different things. It's useful for some, not great for other things. Using UniqueSeq, using the whole mitogenomes, and then designing assays to that. How many regions do you think were represented out of those 125 assays that I talked about? Throw out a number.
4.
Okay, 4, 6, okay. 25, okay. Well, the number is, great guesses, the number is 14. And out of the top 4 that like reoccur, and that Koan is not one of them. You probably want to know which ones they are. Cytochrome B is one. And then the other ones are all NADH dehydrogenase genes. Who would have guessed? Kind of cool. So we've generated 324 high-quality, complete, standardized mitoGenomes, and these are representative of 119 species. These are all uploaded into GenBank, and so on. It was difficult to upload it to GenBank. That's another story, but well. Anyways, but those are there. Now, what I want to do is I want to highlight a couple of applications that we've used these tools in. Some that haven't yet been talked about, like in terms of the applications. So this first one is actually a study that we did with the Chippewa Prairie Dene First Nation. This was like one of our first forays into this realm, and they wanted to know where Arctic grayling was overwintering on their territory. And through indigenous ecological knowledge, the elders knew that there were overwintering spots in 4 places, but they wanted to use eDNA to help support that. Now, overwintering, you can imagine, it's really hard to drag a seine net through ice and snow, right? So, so here's a picture of members of the community that are using an auger to drill into places along the Christina River. And long story short, out of the 4 sites, we got 3 out of 4 hits, like really strong hits for Arctic grayling with all the appropriate controls and everything like that. That was exciting. And then we're like, okay, well, what about number 4, site number 4? Well, it turned out that the quality of that sample was compromised, and we were able to identify that it was compromised through the use of what we call integrity DNA test, which is based on a chloroplast segment that it's an endogenous control that we use on every single sample that we ever test to tell us whether a sample is degraded or inhibited. In that case, it was a degraded sample. And so that would have been a false negative had we not known that. Now, another fun thing that we did was also with Chippewa Prairie Dene First Nation, as well as the Cold Lake First Nation, and Environment Canada, and Alberta Environment Parks, or whatever they're called now. They've changed the names a lot. Is using sediment cores. So this is an example of the results from a single lake, Cowper Lake. And of course, this is in the, I should have mentioned, is in the oil sands region of Alberta. And this looks really, really complicated. But basically, you got a core that of sediment that was taken from the middle of the lake. Then the core was sliced and diced and dated. So we went from 1900 all the way up to the present, and then we took we tested for fish using our eFish1 assay, sort of general fish assay, and then also we're looking for a couple of other species in there. But the one I want to highlight of fish in these sediment cores to determine a historical baseline is the cisco, which is the top fish on the left there. And the elders said that the cisco, that white fish, was there before in Cowper Lake. They haven't seen it for a long time, but it was there before. And they wanted to see if there was evidence using eDNA, like sediment eDNA, was there evidence of the existence of this fish. So you can see, or maybe you can't see, I don't know, they're small, maybe not, oh, there, that in fact, so this is a lighter colored fish here, so you can see the dark one is fish throughout, so we could get fish DNA from a lot of the cores. And the light fish here, all the way up to about 1940, we could detect in multiple samples the presence of DNA from that fish. After that, nope, all gone. Now, interestingly enough, this was done after, this graph was generated from randomized data. So when we get our samples, we actually, one of the technical things we do is we actually blind our technicians to the samples and randomize the samples so that we lessen technical bias. So when you get something like this after decoding it, oh my God, is it cool, you know? Anyways, bottom line is that we actually did show that there was DNA in that sediment from the 1940s previously, and it turns out that when we went back to the elders with the results, they said, oh, you know what? There was a part of a hill, like a big chunk of a hill that just like broke off and fell into the lake around that time. And actually, using other analysis like sedimentation rate analysis, that actually corresponded to that event. And so rather than Cisco being like impacted by development later on, which didn't happen until like after the 60s, we actually were able to sort of pinpoint that it was related to that event with the hill falling into the lake, probably causing issues with oxygenation, and they died. So another thing I wanted to show you, and I'm going to whiz through this bit here, is another application which actually involves eRNA. So we've heard a lot about eDNA, but eRNA, well, it's a nucleic acid too, and it actually has the neat feature that it can actually tell us something about physiological state of an organism, or like alive or dead, potentially, okay? And so we teamed up with folks at NRCan and FP Innovations to apply these principles of eRNA and eDNA methodologies to actually get after wood products that are infested with pinewood nematode, which is a very bad nematode for everybody except for, like, in Canada, because it's endemic here, no problem, but they tend to kill pines in other suitable habitats globally. So it's an export problem. So the way to deal with that is that they treat the lumber with either fumigation or heat, and that. But the way that they actually test for pinewood nematode is this long protracted process where they have to like drill a hole into the lumber product or whatever, and then they put it into these Behrman funnels that are lined up there and add a little bit of water, and then they literally wait for any nematodes to swim out. And then if they swim out, they have to look under the microscope, and then they have to identify it, either identify that there's eggs there from pinewood nematode, or there's like juveniles or adults, okay? So that requires some taxonomic expertise. And the thing is that pinewood nematode is the only member of the genus. So it turns out there's a whole bunch of other ones, Brucophalanchus of various sorts, that are not a problem, and they have to be able to distinguish between the problematic one versus the ones that are not problematic based on features in like the tail spike hooky thing. I'm really a taxonomist here. Point is, it's hard, even for the experts. So what we did was we took advantage of the fact that they were genetically distinguishable, and created eDNA and eRNA assays. But how do we pick which RNA to use? So with RNA, we want to pick something that is indicative of a killing event. So like if the lumber product is infested with the worms and they are put into a kiln or whatever, we want to make sure that it's showing that, okay, they're dead, right? So we did this experiment, different temperatures and stuff. There's a kill temperature, 56 degrees, but we did a graded experiment going up. And we looked at eggs, juveniles, adults, because those are, of course, important to be able to identify. And what we had to do was we used RNA-seq in order to identify which out of the 10,000 plus contigs actually are behaving in a way that are a potential indicator. In other words, they're high at non-kill temperatures, but then it plummets at the kill temperature. You want to guess how many out of the 10,000 contigs followed that pattern? 2. Absolutely. 2. And the student that was working on this was going halfway crazy, but went through all of them and carefully looked at this. And it had to happen for all 3 different stages too. Okay, so what do? So then we created assays based on those contigs. I won't go into the details about that. They're highly specific. It picks up the bad guy and not the good guys. And then we married those assays with our integrity tests to help mitigate false negatives. And we also have a false positive check in that we test for the DNA of the bad nematode. So basically it's a 4-part assay. And what we're looking for, if phytosanitation was effective, it actually killed the organism. If it was there, it would be like on the left, the RNA would be greatly decreased, gone. If phytosanitation failed, it would still be measurable. And so we did the experiment, and in fact, the end result is, with all the controls and all that kind of stuff, it worked. Yay. So where we're at now is actually going from in the lab wood blocks that we tested this on that were infested intentionally with the pinewood nematode, and actually bringing it out into the field where we can maybe do swabs of lumber and fun things like that. So that's where we're at with that. I think it's really cool. Okay, so competency, the next thing. So we've already talked a bit about standards. We're going to talk more about standards with Ken, but part of the OddTrack DNA project was to support the creation of the second standard, which was the qPCR proficiency, the performance criteria for qPCR assays. And I'm very proud to have contributed to that, and thank you to the community members and the public that actually contributed to and commented on this very, very important standard. Now, in the last little bits, I'm just going to fly through another important segment that we're working on right now, and that is to help support proficiency testing. Proficiency testing is a thing which is really important when you want to make big decisions on things and you want to be confident about the tools that you're using. So it's a foundation for diagnostics and so on. And so we started to tackle that and trying to understand what the pinch points were for if we were to set up a proficiency test. So how well, does one service provider work compared to another service provider? Are they all reliable? Are some reliable? Are they all really crappy? Who knows? And this is something that is important in ISO accreditation for labs also. So the general setup for proficiency testing usually involves having somebody act as a reference laboratory, so they create a reference, and then you have a provider laboratory that then like prepares the materials, and then they distribute it to the participating labs. Okay? So, seems simple, and it's really easy for like, you know, a blood test or something, you know, but we're talking about eDNA here. So it gets a little bit complicated because there's a lot of steps that we have to go through. So how can we set up a proficiency testing framework? So what we did was we did a big interlab validation exercise that had multiple components, and it was kind of graded, like we started like with baby steps, like, okay, we've got this really nice performing assay, targeted assay on northern leopard frog. What if we send like all the reagents, all the enzymes, everything to 18 participating labs all around? You know, there were like 7 USGS labs, or were like labs that were in government in Canada, labs that were in industry in Canada, and also like service providers and things, and then academic labs. Okay, so a whole gamut of that. And then ask them to run on their machines with their people, with, you know, some have robots, you know, the fancy ones, they have robots, and the others have, you know, their various pipetters and stuff, and just have a run. And then we task them with basically creating standard curves, and then we compare the results of those standard curves. So we were comparing LODs and stuff. And what do you think? Do you think that when we did that, how do you think they would have performed? So, really good? Yeah, lots of variation maybe? Okay, well, in actual fact, so this is just showing you a portion of the data here as expressed by LODs and LOQs. So you can just look at like the top panel, for example. What I'm showing you here is phase 1 and phase 2. Phase 1 was just one assay and exactly what I just described to you. And you can see like each lab is represented on the bottom scale here. And you can see that like really good reproducibility across the labs. Okay? And after they survived that test, then what we did was we said, okay, you did such a great job. Now, you guys buy the reagents. We'll tell you which reagents to buy, but you know, you guys buy the reagents, you prepare your reagents, run it again, and then run a couple more assays too, just to see. Okay? And they did better. And it was still, you know, pretty awesome. So even using different thermocyclers, all that kind of stuff, generally, it was amazing. Really good. So we thought, okay, great. So now what we're going to do is we're going to introduce the filter. Okay? So we had a service provider, so a provider lab create reference material by grounding up rainbow trout and into little bits, and then diluting it, and then like to reasonable levels that one would expect from like a strong environmental sample, and then prepare a bunch of filters for that. Okay, so we gave them filters and stuff, and we did whole filters in one iteration, we did quarter filters in another iteration, and I'm just showing you the results of the quarter filters and stuff. And there's a couple of take-homes here. First of all, the lab that created the material measured it here. Each little dot represents a quarter filter. So you can see that by and large, the different quarters of the filter are pretty tight. So that's amazing, because it addresses the heterogeneity of filters and all that kind of stuff. But the other thing that you can see is that, okay, pre-shipment from the provider lab, not too bad. This line shows the median here. But when you look at all the other labs here, and each lab did a pair of filters, you can see that the variation is actually between labs is quite large. It's over 2 orders of magnitude. Okay. So that becomes is identifying a challenge in terms of how results can be reported. Everybody that participated was able to detect the DNA on the filters, no problem, but the actual level of quantitation was different. So that suggests that there may be differences in extraction abilities, even though they were using exactly the same protocol. And that. So in the context of a proficiency test, then, that gives us valuable information in terms of what is a reasonable expectation in a proficiency test versus what's not. So detect, not detect, reasonable, getting like actual copy numbers and comparing copy numbers, maybe not so much unless maybe we correct for efficiency of extraction or something. Okay, so these types of information are giving us key bits to help us to make a better proficiency test, which is hopefully coming soon. Okay, so this is a structure of the proficiency test that is suggested by Maggie Hunter and a number of researchers. What our work has shown is that we could potentially put filters into the proficiency testing framework rather than sticking with just like extracted material and that, but we need to make some compensations for that. Okay, last bit in the home stretch. So you all saw eDNA Explorer. Isn't that cool? eDNA Explorer is like super, super cool. I'm so stoked about it. So stoked, in fact, that Rachel Meyer and I have teamed up with the help of Genome BC in order to actually create a Canadian version of eDNA Explorer, which we're working on as we speak. And so excited about this because the user interface is just blows me out of the water. Every time I look at it, it's like, oh, this is so understandable. This is so neat, but yet all scientifically defensible. So this is one of several examples, but I'm excited about it very much personally because of the fact that that the structure of eDNA Explorer and eDNA Explorer Canada address some key issues around data governance, Canadian data, stay in Canada, that kind of thing. Owners of the data, ownership is maintained and controlled by the owners of the data, and so on. And it's also an instrument for building community and that. So I'm very excited about where this is going. And then we already talked about the FAIR eDNA, and it really is fairy. You like that? F-A-I-R-E, right? And if you haven't checked this out already, it is also, I think, a game changer in terms of how we communicate data and work with eDNA data across platforms. So the whole gist of this is really about being able to maximize the use of eDNA data across platforms and that. So again, it's a way to bring community together. Okay, so I know I went a little bit over, but hey, I'm so excited about it. Sorry, and you're my captive audience, so hey. But I hope I've been able to give you some, get you excited about at least maybe one thing that I talked about today. iTrackDNA has really built on, done a lot of amazing things on extensive partnerships, and I think those of you who we've worked with, look forward to those of you who haven't worked with but will work with, and that kind of thing. Thank you, and really it's about building that capacity, breaking down the barriers, and importantly, increasing the confidence of the tools and how we report the tools, like we were talking about before, in amazing ways. And with that, I'd like to acknowledge the many folks in my lab that have been involved with this. I've already acknowledged the many other organizations and folks there, and also the eDNA Explorer team. And thank you for your attention.
I think we have time for one question.
While we certainly support iTrack and the validated assay, how does iTrack consider or warn about phylogeographic differences? Turns out that the northern leopard frog assay doesn't work for Colorado northern leopard frogs. There's a sequence difference under the primer and one of the probe.
Well, that's cool. That's the kind of information that we need to know, right? So anytime a person uses a tool, you always want to make sure that it's the right tool for the job. And as we use the tools under different circumstances, different locations and so on, you always got to validate everything. Like, don't blindly go and use it. For example, the leopard frog assay, Kat's using that one in Arizona, so that's really interesting, and it validated just fine, and is working like amazing. So the fact that you're finding some populations in Colorado where it doesn't work, that's really good for us to know as a community. Yeah. Jen?
I just want to say that in your report, what's really nice is that we understand how extensively it was validated in the different region, and this is what I appreciate with the appendix associated to your publication, which is clear how extended the assessment for specificity was done. So, yeah.
Thank you, Jen. Yeah, thank you for that very nice comments. In fact, for those of you who haven't looked at the paper yet, and I encourage you all to look at it because it's a really, really fun paper, but that appendix is the biggest appendix that I've ever published. It's over 400 pages. But the thing is it has like the sequence alignments, it has the technical bulletins, it has like literally all of the descriptors and how we got there for every single of those 125 assays. Yeah. Thanks, Jen. Oh, Amanda.
Yeah, I don't know if we have too much more time because we got to move into the panel discussion, but I actually was curious about your interlab comparisons. For the material that you were using to quantify, were you using the synthetic G blocks? Yeah, okay, because that's really interesting because this was something that we actually tackled in a project with DFO, where we had a bunch of goldfish ponds, we drained them, and we sampled them using like a grid, taking like 20 samples across like 10 different ponds. And the DFO lab and our lab processed them using the exact same protocol. Like we homogenized the water in each site in a bucket, and then each took a filter from that and then processed the filter separately. And interestingly enough, we ended up with like a 95, when you looked at the concentration across a wide range of concentrations and ponds, when you had, when you look at the sample site by sample site comparisons, the R squared between them was like 95%, and when we looked at the mean pond concentration, the R squared between our labs and DFOs was like 99, so highly replicable. But the one issue that we encountered was that our estimates of the concentrations were, I think it was our lab had always had 70% of the concentration estimated by DFO. And we think that it was from the G block dilution process.
Okay.
So I think that might be something to consider just for these direct comparisons, just standardizing the concentration, but the standards that you're comparing against.
Standardizing the standards.
Yeah,
I love that.
exactly.
Okay, yeah, it's like a circular argument. Yeah, so that's one reason why we did the first like phase 1 and then phase 2 to actually demonstrate or refute that people could get similar results. So those, the LODs, LOQs are based on the standard curves, and you saw how tight that was. So that was not a factor in like the next part, because they used those standard curves in order to generate the next bit.
Well, interestingly enough, our LODs and our LODs and our LOQs were actually pretty consistent. They were a little bit off, but they were tighter than the concentrations assessed in the samples themselves. So it's kind of a weird situation, but yeah.
Yeah, that's cool.
Something to consider.
Yeah, thanks, John.
Okay, we're gonna move on to our community discussion.
Good morning, everyone. Thanks for sticking around. You probably have the driest subject right before lunch, so please bear with me. It may be dry, but I'm going to educate you on the benefits of standards, how we develop the standards, the use of standards, and then I would like to have an open discussion at the end on how do we get the standards adopted for use, and maybe even funding sources for further standards. So we started the discussion 8 years ago. Colleagues and I came to one of the first PISCeS conferences, or the first PISCeS conference, and we came to an audience that didn't really understand standards. They didn't accept standards, the benefit of standards, and we spent lots of time over the subsequent years gathering that support, interest, because standards can support the adoption of new technologies, and that's what eDNA is. And it's been a passion of mine since I started CSA 8 years ago as well. So this was really one of my first projects that we stayed with. However, again, I was tarred and feathered. People didn't understand the benefits at the time. They thought it stymied research. Researchers don't like being told what to do. There was a lot of misconception. So again, we spent years overcoming that, and I don't believe I'm tarred and feathered anymore, as shown by 2 standards currently already published and future standards coming our way. So who am I? Why am I up here? I manage the water portfolio at CSA Group. I do everything water, anything water. It aligns with my background and my history as a scientist. I am a water mutt. I have been an isotope paleohydrologist, and some of my research, Caren, wherever you are, aligns great with your pike data, where extensive droughts occurred in that region at the same time, isolating lakes from rivers and isolating oxbows. So I have some data that might even be able to support you a bit. I have been a hydrogeologist up in the oil sands. I've been a municipal stormwater specialist and water specialist. So again, I'm a water mutt, and that's why I have this portfolio. And the red box is where the eDNA portfolio lies within my natural resources group. So who is CSA? We are a lot more than hockey helmets and toilets. We really, really are. CSA has been around for over 100 years. We were the first standards organization in Canada. We developed the first standard, which was a bridge code, and we've been running with it ever since. Our goal and mission is to enhance the lives of people through the advancements of standards in the public and private sector, as we're seeing with the eDNA standards. And we focus in over 12 technical areas. It includes construction, healthcare, nuclear, mining, climate change, you name it. We are in every sector. We have over 3,000 currently published standards, and about 80% of those have been adopted by regulatory agencies for use. And we generate our standards from you, the experts, with your support, volunteering your time. And of course, I heard earlier that that's a challenge nowadays, but all of our standards are generated by volunteer members. No one is paid to generate our standards. So CSA is broken up into 2 groups, the standard side and the TIC side, or testing and certification side. That's where the hockey helmets and toilets come from. My side on the standard is where we develop the standards. We undertake research, indicating new standards or technologies that need to be standardized. We educate people. We create training courses. We reach out to people and do government relations work to get the adoption of standards at all levels, from municipal, federal, provincial governments, you name it. And then we advocate. And again, that advocacy is for the adoption of standards. So there's a lot of misconceptions about what standards are. A lot of people think standards are guidelines. Well, a guideline is an educated report giving support. Oh, we're running out. Okay. So a typical guideline, it provides background, it educates, it's a much longer document. It doesn't provide the guidance of you should, you shall. So it explains what a topic is and what you need to understand, but not really how to get the answer. A standard is very, very stringent in what it recommends. It provides the guidance for success, the minimum criteria and specifications that you need for success. That way, when we provide the minimum, it leaves it open for research, for elaborating on those techniques and tests. So we provide the minimum for success, but we use very carefully worded phrases like shalls and shoulds. If it's a shall, you must do this for success if you are following the standard. If it's a should, it's a high recommendation, but you are able to do what you please. But the committee members and the experts at the table felt it was very, very important to follow that, but they leave it open for interpretation. So research, that's really what started the eDNA process off. We undertook a research project with Caren Helbing and Jared Hobbs, and that really was a state of the industry, basic, where does eDNA stand, okay? And recommendations for future standardization from that. From that research report, we then started our first eDNA standard on reporting requirements and terminology in 2001 or 2000, and it went through the 18-month process to develop the standard. And then in 2022, we started the iTrack project with the QPCR standard. So this is the scope of the first standard if you haven't seen it. I probably won't read through everything because I am not a technical expert and I'll probably kill it, but that's the first scope. And that is the second scope of the QPCR standard. Again, these are minimum recommendations for success. Advocacy, we have a government relations team. Again, this is key. I need you folks, the users of these standards, to advocate for their acceptance and adoption at all levels of use. My government relations team can go from the minister level down, but we need the users of the standard to really promote the use. Without that, the higher-ups don't really understand what's going on. So how do we generate standards? Well, the standards system is there are over 350 organizations worldwide generating these standards. 15,000 volunteer members generate standards across the world. There's different standards organizations internationally, different certification bodies, different testing and collaboration or calibration laboratories, all fall under the SCC and is audited and monitored for compliance. So the key principles of standard generation, it's open and inclusive. Anyone can sit on any of my committees if you are a technical expert and have the time to volunteer. The members develop the content. I don't recommend anything. I don't come up with a scope. We sit down at our first meeting, we formalize the scope, and it's you, the technical experts, sitting at the table that develops the technical content. I do not guide anything. Decisions are based by consensus. Now, the members here in the room will know it's very annoying to get 30 people, 20 people at a table to come to consensus on some of these very, very technical conversations. But it's doable, as we've seen by the two standards. And consensus is key. If we cannot reach consensus as a committee, it does not get included in the standard itself. We'll put it in a parking lot and we'll revisit it 5 years down the road when we go back to edit the standard. And this is also very important to understand. Standards are voluntary. They are a great technical document. They are wonderful. It's everything you need for success. However, if it's not adopted into policy, it's just something that you can follow at your whim, okay? But once it's adopted into policy, that's when it becomes a requirement. So where does CSA sit in the landscape of standardization? So CSA is the largest standards organization in Canada. We are not for profit. We are overseen by the SEC, or the Standards Council of Canada. They audit all of our work, all of our standards. It's just another check and balance to ensure that we're following all our very, very stringent directives and policies to generate these standards. The SEC is mirrored south of the border with ANSI. ANSI is another standards organization at that national level that we can actually create binational standards if we wish. So we could take some of our CSA eDNA standards and turn them into binational standards to get that acceptance in the states as well. So that's at the national level. Then you get up to the international level, and I know there's been a lot of conversation and work on eDNA standards at the international level as well. So that's something we can maybe talk about after the fact. So how is it done? So anyone can participate on my committee, whether they're American, Europeans, anyone in the world, as long as they have a technical expertise or background in that subject matter and they have the time to volunteer. There is no restriction. What we do and how we set up our committees is we do what we call a balanced matrix. That's where we get equal representation from regulatory agencies, consulting, academia, public interest, manufacturers. We try to balance our committees so one user group cannot really railroad the direction of the standard to benefit themselves versus society as a whole. I can have a committee from 10 members up to 50 members if we want. So there is no limit to the amount of participation on the committee as well. Consensus, again, consensus, consensus, consensus. Nothing is included in a standard without consensus. So any of you, if you're interested after this chat, and I know it's lunchtime, so I'll really rush through this for you, but any of you, if you're interested, can reach out to me, show your interest in participating on the committee, and hopefully after this discussion, we'll find the funding for the third standard, and we'll be generating that over the next 18 months once we get funding secured. So please reach out if you're interested. All committee members at the table have their right to provide the information that they feel pertinent to the discussion. It's an open conversation, no one is turned down, everyone has the right to talk, and then we discuss the technical content after the fact. We do not promote proprietary technologies. We would give a minimum requirement of, say, a centrifuge, which we had a conversation of yesterday. We would not specifically state a piece of equipment, because if it goes out of date and it's not produced anymore, then the standard is out of date. So we provide minimums of acceptance. And your responsibilities are really working for the benefit of all. We've seen this with the first two standards. No one is really pushing research in a certain direction. It is to the benefit of eDNA as a whole. Upholding the consensus process, again, consensus, consensus, consensus. You have to actively participate in the meetings. We have a series of meetings where we discuss the content. We go back and forth to reach that consensus. If you're not at the meetings, then your content and your voice is not heard. So participating in the meetings is key. Unfortunately, I do have a mechanism that if you do not participate, I am able to remove you because we need people participating to generate the content. I've never had to do it yet, but that process is there. And again, we don't promote proprietary technologies. The black box works that is out there. We need to know what's in it so that we can promote it. But again, we aren't promoting the black box, we're promoting the minimums for success that that black box may give so that you could use any different technique. So how we do it, we have an overarching strategic steering committee which guides the development of where we go with standardization. Then we have our technical committees that approve the standards that we develop, and we have our technical subcommittees that actually develop the content. This is a step-based approach for checks and balances throughout the whole process to again ensure that all the policies and procedures are followed. It's an 18-month process. It is a long process, but when you volunteer, you're not volunteering for that whole 18 months. It starts off once I get a contract signed and I secure the funding. I spend 3 months creating a committee out of experts that I reach out to and ask if you will volunteer your time, because it is a time commitment. During that period, I'll contract an expert or 2 or 3 to develop the seed document, which is the first take at the standard itself. So that when I get you experts into a room, I'm not wasting your time with a blank piece of paper. We're not starting from scratch. We have a starting point for discussion already on paper by experts in the community. After that 3 months, that's where the fun begins. We sit down, we have meetings every 3 weeks or so to go through the content line by line. We cross it out, we change it, we axe whatever you wish. It is your document at that stage, and you can take it wherever you want to go on a consensus basis, and that's a 6-month process. After that, it goes out to the public. So all of you that weren't able to participate on the committee, you have an opportunity to review the document in its entirety, provide detailed feedback that the committee has to go through question by question, comment by comment. We have to address every single comment that comes in from the public, be it 500, be it 5. And we have to document the response for each, so that again, we are auditable to the public. After public review, after the committee formalizes the document with the comments, then goes out to editing, all the publication stuff, and that is 18 months. So in total, you would have about 7 months of work with me to develop a standard. What I've done over the last few years is I've been generating a young professionals program with a couple other colleagues in CSA. And what this is we bring on young professionals like yourselves who may not be working at the time. You may be a PhD student, a master's student. You can come join our committee as an observer. You can participate in the process. The intent would be you are a fully functioning working member of the committee, volunteering your time. But it gets you at the table with the experts. It lets you network. It lets you learn the latest things that you may not already know. It helps you with writing. But I think the key thing here is networking. So we are able to fund members if there's travel. It's just something that I feel it really, really benefits the younger generation coming up because you are the future standards users. So if that interests you at all, please reach out to me, and I'd be more than happy for a discussion, especially once we get this third standard kicked off. So funding. This is what I'd like to discuss after the fact, open conversation. We've been trying for 3 years now to secure funding for the last field methodologies standard. The committee wants it, the community wants it, regulatory agencies want it, but unfortunately it's been very, very challenging to secure funding. We came close once, and I wanted to thank the 4 members who were able to participate with some funding agreements at the time, but we just weren't able to formalize that funding approach. So open conversation after this is how do we get to that next step? How can we generate the third standard? Who can we reach out to? Who would be the champion? Who would be the funder to support this initiative? Other things I'd like to talk about today are how can we get our standards more noticed? How can we get them referenced? How can we get regulatory agencies to adopt them for use? DFO, NRC, ECCC, these are all regulatory agencies that are using eDNA technologies in some shape, way, or form. So how can we get that into their policy so that practitioners that are undertaking studies and programs for them are able to use eDNA and follow the standards? Education. At CSA, we develop training materials. We develop online courses. You know, my hope for this field methodologies standard is to develop an online training course for anyone that wants to be a field sampler and really focus it on uptake in the indigenous communities where they can support researchers, where they can go out and sample their lands for others and others' projects, while educating and training and supporting those communities as a whole. Students, again, the opportunity is there for you to come on to some of our committees and participate in network. And then the employees, educating these regulatory agencies that eDNA is a technology that can be trusted for use. It's at that stage now, but we're still getting pushback from certain agencies. So how do we get that uptake? How do we get that support? From the regulatory agencies, the consulting companies, a lot of them seem to be on board, but then they're running into that roadblock of the regulatory agencies, sometimes, not in all cases, stating, sorry, we're still not happy with that technology yet, even though it is at the stage where it can be used. So those are just some conversation points that I would like to have after this if possible. And for any of you committee members, by all means, feel free to start off conversations that you think might help.
We have time for questions.
Thank you, Karen. I was just wondering, you mentioned, can you tell us a little bit more about this third standard you're developing and its field methods, and is it terrestrial, aquatic, air? Like, can you just give us a little more?
Yeah, the early discussions are it would be all eDNA, terrestrial, air, water. There's been other conversations, but I think we'd focus on the main ones currently. Again, I'm not coming up with the scope. It would be, you know, Caren's and the Bob's and the Chris's and others, but it would focus on all of the types of eDNA currently being used.
What immediately comes to mind is the complexity and the amount of ecologists who understand these systems, because as Pierre said during the panel, I think that's an important backdrop to how you tackle the field sampling, and yeah, it's going to be critical.
Yeah, no, I completely agree. And it really comes down to the makeup of the committees and getting the right people at the table.
Sorry, just to add to the answer. One of the purposes of the standards is not to be prescriptive. It's not thou shalt everything. Like Ken described, saying, here's the minimum reporting requirements. So we cannot have one sampling design for all studies, let alone all environments. So that flexibility is going to have to be built into it so that it's not prescriptive and rigid. It's saying to do it right, what are some of the things you need to consider and what information do you need to provide to basically ensure credibility. It's going to be a big job.
Yeah. It will be a fun one to participate in.
Out of curiosity, you mentioned that there's public feedback.
Yes.
How much feedback was there for the first two?
We had, I think it was about 50 comments for the first one and about 60 for the second. Our standards are housed in an online database that anyone can get access with. The problem we have is getting it out to the users to provide that feedback. So we really rely a lot on the network that the committee members have, as well as reaching out through LinkedIn and regulatory agencies as well. So we really try to promote it as much as we can, but that is one of the limiting factors with the public review. People need to know it's there during that time period, and we really rely on the members a lot for that. Okay, so funding. Are there any potential government grants, research grants, research projects? For example, we did participate with the iTrack grant, and one of the deliverables for Genome Canada was the qPCR standard. So there's multiple methods we can fund. As you saw with this graph, or slide here, we had 4 members all contributing what they could to start funding that standard. So it can be a collaboration of 15, 13 different companies, organizations, regulatory agencies. It can be funded by one single source. There's multiple different funding mechanisms that we can follow. And again, it's been a challenging 3 years to get that support. And we're just kind of stuck at this stage.
Just out of curiosity, how much funding is needed to develop the standard?
On average, to administer the development and manage the standard for the 5 years that it's out in the public, it's a $200,000 on average cost. So the way I liken that is when I used to work for the City of Calgary, I used to develop standards, and it was about the same cost to hire one consulting company to develop a standard. The benefit of the CSA standards is instead of one consulting company, you have 20 different brains at the table, all with different backgrounds, different interests, all combining that information into a much stronger product. So you might have 100 hours with a consultant, but you'll have 800, 1,200 hours of professional time developing the content of a standard.
Hi, thank you. A quick question on the accessibility to the standards. The last time I checked, they were behind a paywall. So we needed to pay to access the standard, wasn't really available?
So the current eDNA standards are free to view within the CSA store. You just have to log into an account and then you get free access to the standards. If you want to download it, then there is that small fee. Now the reason we have fees in our standards is all of the background work that with the store and keeping everything open. So we do have to receive revenue somehow to keep the store open. Now, an interesting fact is the CSA side of the standard side of CSA doesn't make money. We are a not-for-profit organization. It's the TIC side that actually keeps the doors open with the certification and testing. So we try to offer free view access as much as we can. That is funded by the funder for a 5-year period. But sometimes the funder isn't willing or able to fund that component. So if we can, we offer it. If we can't, there is that small fee access, yes.
Is there, beyond the existing standards and this third one in development for field, is there anything specific for metabarcoding?
That's been a discussion for the last 8 years. Talking to the committee members over the last little while, metabarcoding may not be at the stage yet for standardization. So that was the 4th one in our list that we generated 8 years ago, but we're going to hold off on that one for things to be truthed out a little bit more.
Thank you.
Yeah, and then the 6th one Bob brought up, and it's a passion of his, is data management, a repository for data. I'm working on that as an aside where CSA actually generates and manages registries. We do the carbon capture registry for Alberta. So we do generate databases and manage those repositories. So I'm trying to see if the Canadian Water Association, the new water group with the feds out of Manitoba, if they're willing to partner to potentially generate some of these registries.
Thank you so much for the interesting presentation and all your work on this. I'm wondering if, on the data governance side of things, you mentioned that there's interest in getting increased buy-in from Indigenous communities, and I'm wondering if the CSA has looked at the OCAP principles from the First Nations Information Governance Center, especially on a data management perspective. It may be worth incorporating some of those principles into the standards or referencing them in some way?
Oh, completely agree. Currently, CSA has a massive initiative underway on how to engage Indigenous communities. As we all know, to be very blunt, every research project, every professional project, and their dog wants some kind of Indigenous support. And the capacity just isn't there. So we're looking at generating a grouping of elders at CSA that would look at our standards and provide guidance on where we need to undertake outreach and engagement. I'm working on a project now that we've actually delayed 6 months so that we could hire some traditional knowledge leaders to undertake workshops across the country for some natural asset standards that I'm working for. So we're really, really trying to up our game on Indigenous engagement. It's just very, very, very challenging to get the right people with the right knowledge base at the table, because one of the hurdles we're coming up against is compensation. And as per CSA directives, we currently don't pay to support the initiative. So that's a hurdle that we're trying to overcome right now as well, because the value there on many of these water standards is incalculable. So we're really stepping back and coming up with a very thorough, detailed process of engagement. Yeah. And actually on that note, if any of you know of any Indigenous groups that would potentially help fund those types of initiatives. Again, all of these things come down to funding. We are not for profit. We rely on regulatory agencies and companies and consultants to fund the development of these standards, as well as the engagement. So we're looking for partners to help fund the Indigenous engagement pieces.
I can speak loud. So it's great that you're talking to CWA. Are you getting any traction?
Not much at the moment.
Yeah, they seem to be another musical chairs.
Yep.
From what I can see.
Yeah.
The other one that might be worth talking about. The Canadian Waters Agency is new. It's trying to find its legs. May not be an immediate partner. Do you guys work at all with StatsCan?
We work with every federal agency.
Okay. Because StatsCan a couple of years ago, and I know under current geopolitical situation things may have changed, but they wanted to start a census of the environment. And they were trying to figure out how to do that.
Mm-hmm.
To me, they seem like they could be a natural partner as potential users of this kind of data.
And that's the thing, there's so many users, and I was hoping the Canadian Water Agency would really step up because they have a whole group on data. That's the overarching group name is data. But again, getting traction is the challenge with these current economic times. One group that we're looking to reach out to for funding for this standard is DoD. They are getting a lot of funding currently, and there could be some opportunities there. So if anyone has contacts at DoD, please reach out to me, and that would make it easier to get in.
Well, some of the consultants may have better knowledge of them. I mean, I know there have been some projects looking for species at risk on some of the ranges where they, explode ordnance and things like that. So it doesn't seem like too far-fetched to think they would get involved.
No, exactly. There's a lot of interest in this next standard, a lot. There's just very limited interest in funding it. Yeah.
You have to have the ecologists at the table too.
I think so.
There's also Science and Technology Canada.
Okay.
We're looking into.
Thank you.
And the Canadian Water Agency.
Yeah, it's been a challenge.
And I don't know that agencies.
I'm not convinced that agency sort of knows its mandate, and in terms of how it's viewed in industry is not so, they're cautious.
They're having growing pains.
They have enough layers and difficulties of regulatory agencies to deal with. This added one on water is kind of like,
Yeah. Yeah, it's been a challenge. Okay, so funding, how about uptake, adoption, use? There was a great presentation yesterday where someone mentioned that they referenced the CSA standard. That helps us in the uptake and adoption of these standards. So if you ever do use them for any of your work, please reference them. Regulatory participants here, please talk to your directors about the benefits and the use of adopting them within your policies. So anything you can do benefits the uptake of the standard, which then benefits the community of eDNA as a whole.
The one challenge I can foresee, just harkening back to our discussion this morning about, first you have to define your question. You're looking at absence, presence, and then potentially air, water, soil. I'm struggling a little bit to figure out where you start with something that's so general as to encompass all of that and still valuable. So I think that will be the challenge that we have to sort of tackle. Is this a four-part? I mean, you don't want to have to go through a $200,000 exercise for positives and negatives and air and I mean, that's not reasonable either. But gosh, my head kind of hurts just thinking about how we would frame this.
That's why you're on the committee, Bob. Just to put you on the spot. If there's no more questions, I'll be around. Feel free to come out and see me outside during the lunch break. More than happy to discuss any of your participation on these committees, on past committees, on any of my water committees if you have interest. Invasive species, endangered species. You have ideas for standards, by all means, just come and see me anytime.